Data pipeline maintenance is an inevitable part of data engineering. In this 2-hour course, we're going to be covering all of the things like how to do a good data migration, how to set up runbooks for your on-call rotation, what are different ownership models that you can do so that your data engineers do not become burnt out. And we'll also cover common ownership problems and maintenance problems that come up that I've seen throughout my career at Facebook, Netflix, and Airbnb. I hope you enjoy the course today. And if you want to do more of this stuff in the cloud, you should check out the Data Expert Academy in the description below, where I can get you 20% off. If you're a high-performing data engineer, this is something that is a fear that you will have as you grow deeper and deeper into your career, is every time you build a pipeline, it's not like you just build it and it's done. Right? If you build it and then you have to maintain it, there's like this continual cost. So like in some ways, like there's this, I've always had this fear where it's like, doing data engineering is inherently unsustainable because every pipeline you write has an added cost. So that means that like as you build more pipelines, eventually you're going to have too many pipelines that you can't maintain them all. Like that's just like the nature of the beast. That like literally there's like, it's an inherently unsustainable pattern because of that. And so, I that's why I have this, the way I like this, right? Every pipeline you build slowly crushes you with maintenance costs. Because if you think about it, like, okay, if you have one pipeline and then, say every pipeline you have has a 10% chance of failing on a given day. So if you have one pipeline, that means that on-call is going to have to do something 3 days a month. If you have 10 pipelines and there's a 10% chance of one of them failing, that means the on-call is going to have to do something every single day. So, that's the thing to think about, right? As like you have, more and more pipelines. And then it's like, if you have 100 pipelines, okay, now on-call is projected to do 10 things every day. They have to unblock 10 pipelines, all right? Okay, what are we talking about today? So, there's going to be 4 pieces that we're going to talk about today, and we're actually going to be breaking out into breakout groups a little bit today as well. So we're going to be talking about the difficult parts of the data engineering job. We're going to be talking about the ownership models of data sets. We're going to talk about team models for data engineering, and then also common problems you run into maintaining pipelines. Those are going to be the 4 kind of big areas that we're going to be covering today. And hopefully this can shed some light on some stuff. And in that ownership models of data sets, that's where we're going to be covering a little bit more around what on-call looks like and all that kind of stuff, especially in regards to what it looks like in big tech. So let's dive a little bit into this like first problem here, the difficult parts of the data engineering job. So I think that a lot of times people look at data engineering, data science, and they're like, wow, those guys, they write like 5 SQL queries and then they're just like done. They're done for the day. And then they just go sip on martinis on the beach and then they're vibing. And that's actually not the case. Like, it's very far from that, actually. If you Google data engineer burnout, the numbers there say that like something like 90+% of data engineers are experiencing burnout right now. So that's like, welcome, right? Welcome to the burnout club. I hope you enjoy it. It's worth it in some ways. So, that's a big thing to remember as you're like going through this kind of data engineering journey, is that you need to protect your peace. You need to protect your well-being. And that is going to be something that will be very good for you as you kind of go through your career, because if you don't protect your peace, like data engineering is going to eat you alive. It's going to eat you alive. It's not like, it's not a forgiving field in that way. So, that's one of the things that I think is why, not as many people are doing it, because you kind of have this combination of things of like why I think data engineers get paid really well. Even though like to ramp up as a data engineer does not take that long. Maybe it takes like 5 or 6 months. But my perspective on why data engineers get paid significantly well is, one side of it is you don't get that much recognition for your work because you're kind of in the backgrounds, and and like the data scientist or the data analyst is going to be the one who presents the work, and like you don't get the recognition. And a lot of people want that kind of recognition when they do their job. That's one piece of it. And then the data analyst and data scientist, they don't have to do on-call. So they also don't have to wake up at 3 in the morning to fix the pipeline. And so, like, they also get, so they get all the credit for presenting the visualization and they don't have to do any of the work. So that's where I think that there's like a lot, like data engineers really are kind of like the unsung heroes of the business analytics environment. And I think that that's something that is really great and can like, but it's also reasons why, like being that unsung hero who wakes up at 3 in the morning, who doesn't get recognition, like it can suck. It can honestly suck really bad too. Right. And I've been there as well. I've been there as well in my job. And when I've been like, dude, I freaking hate my job right now. I don't want to work. I don't want to do this anymore. Right. And I mean, that's why like I've jumped around a lot. And I feel like that's been a part of why I have been I've job hopped quite a bit. It's not just for like I'm chasing money or chasing new titles or getting promotions or whatever, but like also just from the angle of like, at least at the first, like, the first couple months of your job, they don't expect you to be on call. Right? Like usually you join the on-call rotation like 6 months in. So at least the first 6 months, like you're like not burnt out because you don't have to worry about the maintenance. And that's kind of nice. And that's something that I think that's one of the other benefits of like job hopping in data engineering is that like you can avoid the maintenance bullshit. Like that's always really nice. But let's dig a little bit deeper into like why data engineering sucks. Okay, so we're going to be doing some breakout rooms here. Hopefully we're going to have some really nice discussions here because I know there's a lot of people in here who have data engineering jobs. And if you don't have data engineering jobs, some of these, like, you might, like, I want you to think about these more maybe in a hypothetical situation of, like, what would potentially be the hardest for you. So what we're going to talk about today is, or what we want people to discuss in kind of breakout sessions is... we want you to introduce yourself so that you can meet some new friends, obviously. And then we want to talk about like what's your favorite part of data engineering, and then what's the hardest part of data engineering, and then what are some strategies that you've used to implement to make data engineering less difficult and minimize burnout. And make sure to not forget to talk about what your favorite data type is. And like, there's a lot of choices there. You got like Boolean, int, big int, struct, array, like all those different. But you can't just say array as your favorite data type. You have to at least say like why, like at least a little bit more on like what's going on there. So that's kind of like where we're gonna start today, and because I really think this is gonna give the more junior people in this call a lot more perspective on what they're going to be going into, and I think the more senior people, they could learn some more strategies potentially on like how to manage this stuff and minimize burnout. My summary of the three that I think of when I'm like I don't like data engineering is you have like high expectations and that kind of lead to burnout. You have data quality issues, and then you have unclear priorities and ad hoc requests. Those are going to be the three kind of buckets of things, and we're going to go more into detail on each one of these different topics. This is kind of the idea. Like these are the three kind of areas, right? We have high expectations, data quality issues, and unclear priorities are going to be the three kind of areas that make data engineering hard, and I think are going to be some of the most difficult things, and why I think a lot of people leave data engineering is because these problems, like even at the best companies with the best people, like they still do not manage this correctly. Okay, one of the things that I think is very interesting about data engineering is building pipelines and building out infrastructure for companies. It should be viewed as a marathon. It's similar to like you imagine like when back in the 1950s and 60s when the US was building out the highway system, and they instead of like there was like a big pressure to build it as quickly as possible, and then they're like, just slap the highways together, just do it, just freaking, it doesn't matter the quality, just freaking slap it together, and we're just like, because we want these highways built as quickly as possible. And if you imagine like if that was the priority of things, like we'd have like really terrible roads, and that would be kind of a gnarly sort of problem. And I don't recommend doing that. I don't recommend slapping together your pipelines. I think that every time that you do that, you're going to eat pain. Every time. Like every time that I've cut corners on a pipeline to get a data set or to get an answer to someone faster, I've always regretted it. It's like never been something that I've been like, wow, I'm so happy that I got that to them 2 days early to get them to get everything ready to go. But because then it's like always they'll come back to me later and they're like a quality issue or like or it's missing a column or like there's like you almost always like if you rush a data pipeline, you're gonna eat pain in the quality bucket, in the completeness bucket, or in the maintainability bucket, where like maybe you do write it complete and it has the quality, but like then it's not optimized and it's like not the fastest it could be, or like it fails. I've generally found that like you're gonna eat pain in one or more of those buckets if you rush your pipelines. But on the flip side, analytics is a sprint. If you are a data analyst and you're trying to answer questions about the business, the faster you can answer the questions about the business, the better. There is a side of that is important for analytics to answer things rapidly. So there is this kind of like push and pull between data engineering and data analytics. There's like this push and pull. And one of the things that I've noticed in my career when I've done this stuff is, and I was a lot more naive at one point in my career. I remember 2017 is the year that really stands out to me where I did not obey this rule right here, where I'm just going to go over a little bit about like a quick anecdote. So I used to work in notifications at Facebook, right? And then in the end of 2017, Facebook saw its first drop in growth ever. And people were freaking out. They were like, what's going on? Like, how do we fix this problem? And analytics team starts freaking out. And then they were like, Zach, you're a good data engineer. You're a rock star data engineer. Like, we're going to move you. You're not going to work on notifications anymore. You're just going to work on this hard analytics problem of like trying to diagnose why growth is not going back in the US. And I was like, okay. And the thing that happened for me that I realized was, that I treated that problem like a sprint, and then that sprint lasted like 7 months. And I was like, essentially, that's why I have this rule here that says, say no to sprinting the marathon. We're not like that one guy who can run a sub 2 hour marathon. Like there's a couple genetic freaks out there who can, sprint the marathon, but they're few and far between. Most of us need to have a little bit more balance in our lives. And that's one of the things that ended up happening for me when I was working at Facebook was like I sprinted that marathon, got really burnt out. I ended up hating my job, and then I quit. I left because I was like, I don't want to do this anymore. And I got like just so much emotional turmoil in my soul from doing that. And so a big thing here that I've noticed in my own life is, and this is something that I changed my perspective on when I worked at Airbnb. And I feel like I actually had more impact at Airbnb in some regards when I'd made this change, where one of the things was like, when I was working at Facebook and trying to diagnose this growth problem, I literally felt like it was life and death. Like it felt very fight or flight, very like intense. I had a lot of anxiety about like, I must solve this problem. Like otherwise like my company's going to die. And I felt like a very like kind of personal responsibility for the problem, even though obviously Facebook has tens of thousands of employees and I'm just one data engineer. And it's like looking back on it, I'm like, wow, I was like really naive and really like young and stupid. But one of the things that it's one of the quotes that I say nowadays whenever I feel this pressure to sprint. One of the things that I always say, at least to myself, and sometimes to my analytics partners, but usually just to myself, is that we're not saving lives here. We're not saving lives. We're not, this is not a life or death situation. If I get you the data 2 days late, it's probably going to be okay. It might even be exactly the same, because if I got you the data 2 days early, it might take you 2 more days to set up the presentation with somebody anyway. So, because businesses, they don't move very quickly anyway. So, a lot of times if things are a week or 2 weeks delayed, it's not going to be that big of a deal. And that, you want to be careful about, how much pressure you're putting on yourself to deliver these values. Because I mean, I don't know. Like I look back on a lot of my career, especially like a lot of the time near the end of my time at Facebook and through most of my time at Netflix, where like I did not learn this lesson and I just felt like I could sprint the marathon. And that's exactly what I did was I just sprinted the marathon the whole time and gave up so much. And like what I gave up was I don't know, my social life. I gave up like kind of my peace, and I just was like running on anxiety and a dream. And like I don't know, I look back on those times as like I don't necessarily view those times as necessarily I was happy. That like I could have definitely probably had the same impact as I did, but was happier because I was able to view the work through a lens that felt less critical, that felt like it was at the accurate amount of urgency, not like emergency room urgency, like we have to save someone from dying, but also not on the other end of like it doesn't matter at all, because like if you put it all the way over there, then you're gonna get fired because like you don't care enough about the job. So you got to have like obviously there's something in the middle there that is the healthiest amount that you should like care, or the healthiest amount of urgency that you should use in your own job. Especially this problem with urgency is something that's a lot more common among people with ADHD, where a lot of people with ADHD are they're considered time blind, where it's like people with ADHD, they can think in two times. It's either now or not now, and there's no like in between. And so that's like one of the things that I've been kind of trying to shift more in my own life, and that's why I feel like I was able to have a lot more balance and a lot more be able to do a lot more other things when I worked at Airbnb. That's why I was able to like post on LinkedIn and become a content creator and build all this other cool stuff, because I had a better relationship with my work, and I was able to think of my work as a marathon, not as a sprinted marathon. So I hope you learned something here. A key thing here is we're not saving lives, right? We're saving companies money, but we're not saving lives. Okay, so we're going to talk about ad hoc requests a little bit. So a big thing this is another common case of data engineer burnout, happens because of ad hoc requests. I'm going to talk about like kind of a strategy that I've used to essentially eliminate this problem or make it a lot more manageable. So analytics need to solve urgent problems, but to them everything is urgent a lot of the time. And but one of the things that I like to say when I'm talking with my analytical partners is like, if everything is urgent, nothing is urgent, because then everything is the same. And then like urgent means that you have like you have some sort of stack rank, right? And there's a priority queue, right? You can sort things that way. Generally speaking, I like to think of it as every quarter you should spend about 5 to 10% of your time on ad hoc requests, which means that half a day. Keeping in mind that's half a day a week. Half a day a week, or across a quarter, it's like a week, maybe 2 weeks of a quarter is how much time you should be spending on ad hoc requests. The other 13 weeks or whatever should be spent on more long-term infrastructure building projects. So a lot of times this is where when you're doing ad hoc requests, like you should operate from an angle of like ROI, where if the ad hoc request literally is like quick, like there's that meme ad hoc request, which is like, can you just pull this data? And if it literally is that easy, which like on a 1 in 10 times it is, then just do it and like do the 10-15 minute thing and unblock them. But a lot of the times it's not. A lot of the times it's actually complex, and it's actually a project that they need. And most of the time, what you want to do, at least like the thing that I've seen work the best, is something that needs to get put on the roadmap. So that means that like when if they're asking for something that's really complex, then they should be asking it in January, in March, in June, or in August. I guess would be the times. August, September-ish. Those are going to be the times that are going to be the best and most effective times to ask, so that like they can get into the quarterly plan, so that you can as a team, you can figure out the right ways to kind of process this work, the right ownership models, the right data models, right? So that it doesn't feel like you have to just slap something together real quick, but you can actually think about it holistically. And I've noticed that like if you have a strong engineering leader as your leader, that this is something that works really well. But if you have a kind of a weak engineering leader, what ends up happening is analytics overwhelms the data engineers. And I've seen both happen. And like I've definitely been in both situations. So like a part of this really does depend on who your manager is, on like whether or not this pattern can work. But generally speaking, that's the way I would think about it, is like if it's a low hanging fruit ad hoc request, just do it. And that's some of them. It's less than half though. If it's a more complex one, push back and ask them to essentially wait till the end of the quarter. And for them, they might be like, wow, that's a long time. And then that is where it's great though, because that's going to make them angry. It's going to make them frustrated because you're like, yeah, I'll do it in 2 months. Right. And then they're going to be like, wow, like you don't have, like, you really can't squeeze it in the next like 2 months. Right. And so, but the big thing there is that like you need to cause your analytical partners pain, because the only way that you can change behavior is with pain. Only way. Because if you just do what they say every time and like you just burn yourself out because like you just keep saying yes to every single request, they're not going to change how they interact with you. They're going to keep doing the same thing. And that's where like if you cause them a little bit of pain, cause something to be delayed, right? And then they have to like explain why it's delayed, then they're going to like try to figure out a better working model with you. And that's where I love quarterly planning, where then it's like you work with them and then like you come up with a nice master plan and then you're going to execute that over the next 3 months. And then it feels very planned out and methodical. And then you also have time to like a buffer for things like on-call and things like data quality issues and other problems that can come up, as opposed to having to buffer for more work. That's like, I think, a very important thing to think about, like when you're doing these ad hoc requests. It's probably one of the most important parts of managing your workload as a data engineer. Okay, just kind of some more pieces of wisdom on this slide here. Most analytical questions are less urgent than they appear. Comes back to we're not saving lives. There are some small exceptions here that I've actually noticed. I just want to give another anecdote here really quick. So when I worked at Netflix, I worked on this project called EDR, which is external data request, which is similar to like when, you know, if you go to like Facebook or LinkedIn or like whatever website and you're like, give me my data, and you do like a GDPR request and then they have to give you all the data that we have on you. It's like that. It's a lot like that. That's what Netflix has, that they have EDR. But like the thing is like sometimes you get these EDR requests from like law enforcement because they're like trying to like solve a kidnapping or something like that. And then I don't know, like I guess that's like an edge case where it's like, okay, maybe this ad hoc request, like they're solving a kidnapping, maybe it is a little bit more urgent than like I thought, right? That's like, maybe that is like the one case where it's like, yeah, we actually are saving lives right now, right? That like, at least in my experience, like that wisdom of we're not saving lives, that's the one time that I've been like, okay, maybe we actually are saving lives. But like generally speaking, that's not the case, and things are less urgent than they appear. You don't need to have that data ready as quickly as possible, and especially if it's coming at the expense of like your longer term impact work, definitely consider that. And this is what I was saying before, like make sure to bring all your analytical partners together at the beginning of the quarter and plan stuff out, and don't just let it be like week to week, like what you're going to work on, because that is not sustainable, because like they're going to keep putting more and more work on your plate every week, and like by the end of the quarter you're going to have 2 quarters of work. So that's like the way to do it, because then it also causes them to think about things more strategically as opposed to tactically. Because if they think about it like if they just give you work as it comes up, then they're just gonna just keep being like, oh, here's new work, here's more data I need, here's more data I need, right? And then like they're not even thinking about the order that you should do these things in. They're just saying, I need this, I need that, I need this, I need that, I need this, I need that. And like it's not like I need this the most, then this the second most, and this the third most. They're not doing that prioritization effort that they should be, because data engineering isn't free. And like I think that's like a thing that a lot of like analytical partners get wrong. is that they think that like you can just slap a pipeline together real quick and it's essentially free, but it's not. That's why data engineers make a lot of money. But anyways, that's kind of the idea behind ad hoc requests. Like they are tricky, and you definitely want to work with your manager and leadership to like essentially come up with systems where the teams can interact in a way that's more appropriate. This is tricky to do when you are like a mid-level or junior IC, but as you become senior or staff, then you kind of wield more influence at that point. Okay, ownership models. So I think one of the big things that can happen that can also cause a lot of burnout for data engineers is they can own too much stuff. I know this happened for me at Netflix, because at Airbnb. At Airbnb, this happened for me where I was owning like end to end, and like I was like, dude, this is too much. Why do I own all this stuff? It's too much. So like, there's 5 things, right? You have data sets, data pipelines, data documentation, metrics, experimentation. Those are like the 5 things that, generally speaking, have ownership. We're going to go over essentially the 2 most common ownership models and how, like, where there are problems and where things can kind of have issues. So, okay, so this is going to be your most common ownership model, where you'll see on the left you have logging and data exports. That's going to be owned by a software engineer. And then the data engineer is going to own the data pipeline and the master data. And then the analyst is going to own the metrics and the dashboards and the experimentation. That's like, I'd say this is the most common ownership model. The thing about this model is that there is lines on this where, like, for example, data engineers might own aggregate master data, and aggregate master data and metrics are like the same thing. And that's where these lines are not as clear sometimes. And then same on the logging side, right? Where it's like a data engineer might work with a software engineer on a logging specification. And that can be another big way that like they can kind of impact. And that line can also be kind of blurry. So these, like, especially around the edges of ownership, like metrics a lot of the time can be owned by both. Logging can be owned by both, and like there can be a messy stuff on kind of both sides of that. I've definitely noticed those kind of patterns in my career. Like one of the things that happened for me when I was working at Airbnb was that metrics layer, there wasn't enough like analytics people on my team, so I just owned the metrics layer as well, and that was like a lot of work. And because then you're owning like the big chunk of the chain, you're owning like 60% of the chain at that point instead of 40% of the chain. And but here's the idea, right? So you will, like, I personally think that this is the most ideal setup. And then what you do is the one thing that you want to ask here is like, okay, but what if someone has like a business question? Usually business questions are going to be related to metrics. Metrics are going to be mostly where the business questions go, and they should go to the analyst or the data scientist. Like there are some edges there where like if like someone's trying to ask a business question that is like not supplied by a metric, but like it needs, like, you don't have the right aggregation for what this person's question is, then maybe they need to go up a layer and they need to go to the master data, and then they might ask you a question about the master data and like how to query the master data. And that's a very common pattern that I've seen as well. And those are like for people who are asking like a I remember there's a question about like the Olympics, like the 2024 Olympics, that I had to answer for people about like availability around the 2024 Olympics, that I was like, of course we don't have metrics for that, dude. That's like in a long time. But like, anyways, this is kind of the idea. This is the most common ownership model. I'm going to go over to like the next slide where we're going to talk about another common ownership model. So this is another common ownership model where instead, like just like what I was talking about in the last slide, where at Airbnb, I was owning pipeline, master data, and metrics. And then you have the data scientists and analysts who work on experimentations and dashboarding, and you have software engineers who work on logging. This pattern is pretty common at Netflix. One of the reasons Netflix has 2 names for analytics engineers. They call them analytics engineers, but they also call them spanners. And obviously, it's pretty obvious why they call them spanners, because it's like they go all the way from logs to all the way to dashboards. Sometimes they even have analytics engineers own the dashboard too. And it's like, wow, like that's a lot. There's like they just own like the front end, the back end, everything. And I generally find this pattern to be also can be kind of good. I want to go over why I think this pattern is good compared to the last one. In some ways, like, so if you have the data engineer and they own the metrics as well, then it's a lot easier for them to kind of update the metrics because they already know the master data very well. So updating the metrics is pretty easy for them. But the trade-off being that, like, a lot of times the data engineer doesn't have enough time to actually develop enough of the business context that they need to get good metrics, because a lot of times that requires a lot of conversations with product managers and customers and UX people and designers and just like tons of other people, right? And so this pattern is not necessarily the best, even though from a technical perspective, you might be able to make and update metrics faster. So that's kind of the idea behind the two kind of common patterns, but keeping in mind that there can be tension, especially around the edges of these boxes. Okay, where do ownership problems arise, right? I was talking about this, there's at the boundaries. So you can have data engineers that own logging, and that can be a problem because then you have data engineers that are going too far upstream and they're like going into the server. And like, then they're like owning. I remember that was a big thing. I worked like at Airbnb. I was like, I went a little bit too deep into the server, and I'm like, why am I doing this? Like, why is this on me when no one else wants to work on this problem? And like, that was also something that like I found to be kind of one of my own problems, where it's like I wasn't like respecting the boxes as well as I should have. But then on the flip side, like you can have like maybe the data engineer is the guy who's not doing his job, and then the data scientist is the guy who's like, okay, I'm gonna write pipelines now because like I need my data, and I'm gonna own that square, even though like I'm gonna probably write a pipeline that's not that great because I don't have all the skills that I need to write a good pipeline. And then you also have what I was talking about before. We have data engineers that own metrics, and then they get overwhelmed because they own the pipeline and the master data and the metrics and all the business questions. And like the maintenance for that one person is overwhelming. I know for me, that was how it worked for unit economics at Airbnb, where I owned the pipeline, the master data, the metrics, the business questions. I owned all of that. And that was data that was consumed by like 20 teams, there was 20 downstream teams and like 30-ish upstream. And so it was just like a mess, such a mess. And so, and that's where, you can have these like islands. You can kind of become an island. That's why like I don't like this analytics engineer pattern as much, because it essentially says like, okay, make tribal knowledge, have one engineer own everything. That's what that essentially this pattern does. And like in some ways I find it to be more unsustainable than where the data engineer just owns the pipeline and the master data, because then they don't have to have all the business context and and field all the business questions. That's the part that is better, right? About the pattern where the analyst and scientist own more. So these things can happen. You can have a lot of issues here if you don't obey the boxes, right? Because like then you're gonna either overextend yourself or someone else is gonna trample on your work. And so definitely be aware of these things and try to like. I've found like for my own self that like I found myself that I'm just like, whatever, it doesn't matter. I'm just gonna do it myself, and I'm gonna do things that way. And as I've gotten older, I've recognized that like you really don't want to solve the problem that way, because that just goes back to you're going to create a team structure that is inherently unsustainable for yourself, and that you are essentially sowing the seeds of your own burnout by going too deep into someone else's box, because you're essentially owning their work and doing their job too. And that is not what you want to be doing, like long term as a data engineer, because that's going to just burn you out real quick. And so keeping in mind that as like you have like different ownership problems that can arise as you are working your jobs. So what happens, right? What happens when the boundaries are crossed, right? There's a lot of things that can happen. Burnout. People quit. People leave. People get angry. People get frustrated. That's a big thing that can happen. You can also have a bad team dynamic where people blame the data engineer, or people blame the data scientist, or people blame the software engineer, or they think that you're taking credit for their work or doing their job, or like not giving them enough time to shine, and kind of trampling over their potential for promotion. And like, so sometimes you might think that you're like, relieving someone of their work, but then they hate you for it because like, they're like, that was my work and I was supposed to do that. And that was going to be my promotion. But now like you're trying to steal my promotion from me. Right. And so like you can get a bad team dynamic from that. So you don't want to do that either. You want to have good boxes. Right. And that's like, otherwise you get the blame game that happens. And then this last one I think is actually probably the most important. And I noticed this especially with like when I worked at Airbnb, was when I was owning all of that stuff end to end and it was just me, then it was like one of the things that would happen is like I would go on vacation and then everything would just melt. It was like if I took a week off, then like the profitability stuff was just done. It was just like, and then I would come back and there would be like 12 Slack messages and I'm like why haven't we freaking solved this problem yet? Like why won't someone else pick up this context, right? And so that's another thing that you can do, right? And this is an important part of a lot of like pipeline ownership stuff, is that there should be a secondary person on most of the stuff that you're working on. There should be a backup person so that like if you do leave or go on vacation, that like the business can still like get their questions answered. Maybe not to the same level of completeness, because like there's no way the secondary person will have the same level of context as you do as the primary person. But at least they can maybe, answer simple to, intermediate questions about the data sets. So big thing to remember here is like solve these problems organizationally, not technically. So if you are getting blocked, like talk to your manager about it. Talk to the analytics partner's manager about it, right? And like try to figure out a way to solve this problem where the person that's supposed to do their job does their job and you do your job, and you're going to be a lot happier. It's better to do that than to be the hero. It's way better to do that than to be the hero. I've noticed that throughout my whole career, that's definitely a way that I've like burned myself many times. So good thing to think about, crossing boundaries. So like don't do it. That's the main thing I'm trying to say here. Okay. So we're getting close here to I think I have like one or two slides left. And like I want to talk a little bit about this. This is something Stephanie brought up like a week or two ago. I even did a poll. And I was surprised. The poll, LinkedIn let me down. LinkedIn let me down so bad on that poll. So when I asked like, what are better, centralized or embedded data teams, and like, it was like 60-40. 60% said embedded and 40% said centralized. And I'm all about the centralized data teams. I think that it's better that way. Because on-call is easier, right? And you can knowledge share and like you can grow each other. It's great. Obviously, the trade-off is that like those the teams that you support, they have to come to you, and then you have to be able to prioritize it versus other teams' asks as well. So like sometimes those teams might not get their data that they need because they get other teams' priorities take higher than them, and so then they oftentimes might want to go and do something on their own and unblock themselves, stuff like that. That definitely happens. So that's one of the things, in the first slide, I wanted to talk a little bit about with on-call in big tech, because I think that's something that we didn't cover quite as much quite yet. So on-call, generally speaking, in big tech, if you are a mid-level engineer or higher, you're going to be put on an on-call rotation, usually about at the 6-month mark after you've started a job. And usually, depending on how big the team is, like it might be once a month, it might be once a quarter, right? Or like, I mean, for me at one point it was twice a month, and even at one point I was on call for 3 months straight. That was insane. So like on call can be freaking really messy depending on what happens. So what on call is like pipelines break, and some pipelines are very sensitive where they need to land like in a couple hours because they're upstream of a lot of other pipelines. So you have like a lot of pipelines that depend on this pipeline, so we need to unblock it. And so that can happen. And a lot of times, like generally speaking, data engineering on-calls are not as intense as software engineering on-calls. I've been on both. Like I was a software engineer on-call at Netflix. And but data engineer on-call, generally speaking, you can do it throughout the day. Most of the on-calls I've been on data engineering is just like business hours, like it's usually like 9 to 9 a.m. to 9 p.m. business hours. And they might expect you to look on the weekends, but not at like 3 in the morning, but they might expect you to look at some point on the weekends, like to see like if anything has failed. But it depends. It honestly depends on the data engineering team that you're on and like the sensitivity of the data that you have. Where like if you are working in some spaces, like, I don't know, like say you're working on like the personalization data team at Netflix, where that data is absolutely critical for the company and it's very sensitive, like latency sensitive, then in that case, like, yeah, you're going to be, it's going to be treated like a software engineering on-call where you will get a page. So I don't know if y'all have ever heard of PagerDuty. It's an app that can like essentially send you notifications and make your phone freak out if there's like a bug that you need to troubleshoot, and it might be a bug that you need to troubleshoot at 3 in the morning. And it's interesting that that's actually how it was at Airbnb when I started. They wanted me to like troubleshoot stuff at 3 in the morning, and I eventually was like, no. I'm like not doing that, like, and because like what I showed was I intentionally didn't do it for a couple days, and I just let the pipeline fail for a couple days, and then it was essentially like a mini experiment where I was like, see, the machine learning downstream is, so I looked into it, is like for every 1 day that it's delayed, the machine learning is 0.5% as effective, like so it's like it loses 0.5% of effectiveness, and I'm like, dude, that's like not that bad. Like, not that bad. Like, it obviously would probably drop off as, like, it got later and later. Like, if it was, like, 5 days, it's probably not, like, 0.5%. It was, like, probably 0.5%, 5%, 10%, like, or something like that. It's probably going to be, like, a kind of more of an exponential drop. But I showed that, right? And I was like, see, because that's one of the things that you can do that can really help the on-call, like, especially if you have latency-sensitive data. Then one of the things that is important to talk about to maybe make on-call easier on you and your data engineering teams is, okay, what is the consequence if we don't troubleshoot at 3 in the morning? What is going to happen? Like, what is going to be the problems that arise? And like, and then if you can see what the consequence is if the data is a day late or 2 days late, and just understand what the impact to the business is. And like for some things, like it might be like $1 million. Like for Netflix and the engagement that they would lose if the data was that late, it would probably be like $1 million. And then it's like, yeah, okay, well, if it's $1 million, I'm going to wake up at 3 in the morning, right? But if it's like $1,000, like, I don't know, man, like freaking, that's not worth it to me, man. My mental health is worth more than that. Like freaking, like, cause it's like, if it's $1,000 and I have to wake up at 3 a.m. like 10 times, I'm going to quit. And then the turnover is worth more than me leaving the company because of bad mental health is going to cost more than $10,000 because they're going to have to replace me, give that new person more stock, give that new person a sign-on bonus, and probably pay a recruiter, right? And there's like there's like this other cost that they potentially have. So that's where it's important when you're working in on-call to understand, okay, if everyone drops the ball and everyone is just asleep and no one actually responds to an outage or a breakage, like what is the actual consequence? So that you can have conversations with your downstream partners so that then they have clear expectations of like what you're going to do when things break. So that's on-call. And like I hate it. But like it's also an important part of the job for reliability. The other model here is embedded teams, right? And how embedded teams work is like you essentially have 1 DE per team. Like I don't like this model as much because of the fact that this data engineer is dedicated in one business area, but like a lot of times they're not going to have as much contact and information sharing with like other data engineers. And how does on-call work? On-call can be a mess in these situations where like you essentially have like a heterogeneous group of people in on-call where you have like software engineers, data scientists, and data engineers, and they're all on-call like for data pipelines. And it can work. It can generally work. I had that experience and I've like gotten that to work as well. But generally speaking, it's better when like everyone on-call is the same job title, because then you have an expectation of what the skill set is of all of these people. But yeah, these are two different ways that companies can kind of set up their data engineering teams. I've mostly worked on centralized teams, but like earlier in my career, I was definitely working in embedded teams. So that's kind of the idea: centralized versus embedded. I like centralized more because it just feels like you're like on a team. It makes it feel like you're like building something cool with like a bunch of people that you like, especially if it's a centralized team of people that you like, then it's freaking awesome. So, oh yeah, we still got a couple more here. So we're gonna talk about 4 areas here that are probably the most common things that happen during on-call when things break. You have out-of-memory exceptions. You have missing data or a schema change. You have backfills. And then you have business questions. Remember I was talking about how like business, if you own the metrics, you kind of own the business questions as well. So these are going to be the 4 that you're definitely going to run across when you're a data engineer. Let's kind of go over each one individually here. Okay. Freaking skew. So skew happens when you're doing a group by or a join where like there's one key that has a lot more data. So you can imagine like if you were looking at like say notifications and you did like a very, very, very viral post that say you got like a post that got 100 million likes, then there's a chance that you got 100 million notifications sent to you as well for every like that you got. And then that, whatever executor gets that data in Spark is probably going to choke and is probably going to die and is not going to handle all of that extra data because it's all skewed. So there's essentially 3 ways to fix this. The best way is just upgrade to Spark 3. If you're on Spark, obviously I'm going to be talking about this from the perspective of Spark, but the best option is to upgrade to Spark 3 and enable adaptive execution, spark.sql.adaptive.execution. If you freaking enable that, slam dunk, done, solved. It will never skew again. So that's one of the things I like about Spark 3 is that like this problem of skew and out of memory for the most part is going away and is going to save a lot of data engineer sanity. Your second best option is to bump up the executor memory, add some more executor memory, and like, because it's easy. It's like something you can try in like half a second and then be like, okay, I'll give it more memory and see if that fixes the problem. And then like hopefully the next day the data isn't skewed and like, or isn't as skewed and it doesn't keep being more skewed. Because if it is, then bumping the memory is not going to help. And then your third best option, right, is to include what's called a join salt. I'll send you guys a link and I'm going to add it to this slide later, but like I'll show you kind of a link of like how to do this technique where you use random numbers to make it so that like if you have a skewed row that you split it up first and then aggregate so that you don't have to like have all that data be shipped to one executor and it can kind of be split up based on a random number. And that can be another great way to solve your kind of skew problems. So skew, like I always think skew is one of the worst words in data engineering. But that's kind of like, I'd say those are going to be your best ways to solve this problem. And so definitely check that out if you ever are running into like weird memory problems. But you can also get out of memory unrelated to skew. But that's a lot less likely to happen. In those cases, that's going to usually be a symptom that someone like wrote the job wrong, where they like were calling like .collect in the driver, and then they try to collect all the data in the driver, and then the driver only has 16 gigs, right, at the most. And so there's like some like weird gotchas in Spark. We're going to cover a lot of these gotchas next week. But like generally speaking, skew is going to be the main reason why you get an out of memory exception, especially if the job already did run before. And this is like just a random out of memory failure that you're seeing in production later on. So yeah, skew, very annoying. Okay, so yeah, missing data and schema change. The biggest thing here is you want to have pre-checks on this data, especially like if it's data that you don't trust. If it's like data from a third-party API or data that could change anytime, definitely have quality checks before your pipeline runs so that you can fail the quality checks and then your pipeline doesn't even ever have to start. This is where you want to solve this mostly in a collaborative manner, where you want to like find that upstream owner and then ask them to fix the problem if it's someone at your company. If it's a third-party API, then it gets kind of messier, where it's like you might be able to talk with them. Most of the time, you're not going to be able to talk with them. And if you're not able to talk with them, you should change your pipeline code. And hopefully, the new data that you get is good enough. But sometimes they might just turn off the API. I know that's what happened for me in my startup when I was working on my startup in 2020, where I was getting all these Call of Duty stats, and then one day they just turned off the API, and then I'm like, oh, I guess my startup is dead because now I don't have API access, and they're not going to give it to me again. And so that was depression. But there's a lot of different things that can happen with third-party APIs. Generally speaking, if you know the owner, get them to unblock it, and then also try to find a long-term fix, especially if this is something that is like a commonly occurring problem. A lot of times these are one-offs, but like that's where you want to be aware of like if it is a one-off or not. And because on-call changes hands every week, whether or not you can recognize it's a one-off or not can be tricky, because you are only on call once a month or like less, maybe even less often than that. And that's where runbooks and proper on-call handoff can be very useful in identifying kind of patterns in failures so that you can solve the root cause of the failures and not just like unblock and keep putting band-aids on like a broken leg or keep putting band-aids on like a situation that's not going to get better. And so we're going to talk more about that on Thursday as well when we're talking more about runbooks. But that's kind of the idea for schema change. Those are going to be the main things that you're going to want to look at and then once they fix the problem, great, then you can move on with your life and unblock your pipeline and get it going. Or you might have to update your code if the schema change is something that you can't like undo. So that's going to be probably the next big thing that can happen. All right, backfills. Backfills are freaking messy. They're probably like, just like what was said in the chat earlier, backfills is one of the most painful parts of data engineering. So generally speaking, how backfills work is you want to do a parallel backfill into a table that maybe you have a table that's called table, and then you want to name it table underscore backfill, and you want to dump all the data into there first, and then validate it, right? And make sure that things look good. And if they look good, then go ahead and do the swap, where you essentially rename the production table to production underscore old, and then you rename the table underscore backfill to the production table. And then you're done. And that's for small migrations, for things that are like where you're not changing column names, or you're not breaking things, or you're not making a very big change to the metric definition. That can be one way to do it. Sometimes, like if you are working with pipelines that have a lot of downstreams, you can't do it that way because you have to migrate hundreds and hundreds of people. And in that case, you don't do this. What you do instead is you backfill into a table that's like table underscore v2. And then you build a parallel pipeline. So then you have the production pipeline running and you have this parallel pipeline running. And so they're both running, and you have v2 in production. And then you encourage everyone to move over to V2. And then after all of the references to the production table are migrated to the V2 table, then you can drop the production table and then rename table underscore V2 to production. And that's going to be the more painful way to go, because then like there's like a lot of PRs where people are like, they update the table to like the V2 name, and then you update it back to the production name. But you want to do this because if you don't, then like your table names get really weird, because then the next time you want to do a migration, then what you do V3 and V4 and V5 and V6, it's like, you don't really want to do that with data. You just want like production, right? You don't want like the V on it. Like the versioning should only be there like when you're in the middle of a migration, not permanently. And I think that's a mistake that a lot of data teams end up doing, is that like they don't actually do that final step where they drop production and rename stuff, because it's like kind of a pain in the ass. But it's better to do that, because then like people won't get confused, because they're like, if you see V2 in a table name, you're like, is this the latest version though? Like, well, how do I know there's not a V3? Right? And that's why like having tables that are just called like production tables or whatever, then those tables are going to like obviously be the right table to query. But that V2 can give people some doubts about whether or not it's the right one. Obviously, I just talked a lot about this backfill process. Let's go a little bit deeper into this. This is probably a better example, especially for that simpler version, right? So you start with your backfill. and you backfill into backfill table. And then you have this production table as well. And then you have a decision here where you're like, oh, did the backfill finish? Okay, if the backfill finished and everything looks good, then you want to rename the production table to table underscore old. And then you want to rename the backfill table to the production table. So then this backfill table becomes the production table, and the production table becomes table old, right? Great. Then what you want to do is message your downstream pipeline owners and tell them that like there might be a change in the metric or a change in some of the definitions, or some it might break things because columns might be added or removed or renamed, and that can happen. And that's usually fine if things break, because then you're just like, that kind of motivates people to migrate quicker. But they might get mad at you too because it's extra work you're putting on their plate. And then the last thing is like once all the downstreams are migrated, then go ahead and drop the old table and then just work with this new production table in backfill. So like this is like the most common pattern I've seen with backfill that I would recommend y'all like kind of learn. Obviously there is that other one with that V2, but that's only like the only time you want to do this like V2 one is like when you have a table that has a ridiculous number of downstreams. Like if it has like more than 30, that's probably when you want to like look at like that other way of doing it where you have a parallel pipeline that runs in production with the other pipeline. But generally speaking, you don't need to do that because you can just migrate the downstreams like while you're working in this process. So that's essentially how backfills work. Business questions. This is another common thing that can happen where if you own data sets, like people are going to ask questions about how to query the data sets, how to like get information out of the data sets. And like, you might have a channel where people post questions. And then a lot of times you're going to want to set a clear expectation of like, okay, we'll get back to you in 2 hours, or we'll get back to you in a day, or like whatever, because then it won't frustrate people if they just post something and then you can't immediately get back to them. The key thing about this SLA is to give you space so that you don't feel like you have to immediately respond when you're on call, so that you can still have a life and still like do other things and maybe even still be productive when you're on call, because there's a little bit of a gap between when someone asks a question and when you have to respond. So setting an SLA there is great. Also, like you're going to get the same question over and over and over again, and put it in a doc. Just, and then like, because then you don't have to keep answering the question. You can just point people to the doc, and then you can get more efficient that way. And then another important question here is to ask like, is the business question on call the same as the pipeline on call? Is it the same or is it different? And that comes back to who is owning stuff. A lot of times, like, you know, at Airbnb, when things are working the right way, then they're different, because this business questions on call is actually like the data scientists and analysts. They do this on call, and the data engineer will just do the pipeline on call. But then, you know, for me, in some cases, I was doing both. But you want to make sure that you have this in here, and like try your best to just not do this. Essentially, like, I don't know, in my perspective, like I don't get a lot of joy of doing this on call, and I like the data scientists to do this on call. But I know that's just my perspective for kind of business questions. Awesome, everyone. Thank you for coming to this one. So next time we're going to be talking more about runbooks and how we can essentially cover a lot of these problems that reoccur in a way that makes on-call more streamlined. So I just want everyone's back. I just want y'all to like drop in the chat like what you thought was like the best part of data engineering. Like what was the thing that y'all like really what gets you to come in and actually, you know, show up every day? So we've got like problem solving. Anyone else have any other thoughts on like different pieces of the? I like that. Like I like the long-term value, Bargov. I like that, like the creating data assets which can be harnessed for value. I like the idea of that, but like with like one more caveat, which is like I like to create data assets that are going to provide value for many years. Like it's like I almost think of it as like I like to create information highways, right? Where it's like being able to like really provide a lot of like truth, like almost like truth highways. I don't know. That's like when I think about like the part of data engineering that really sparks a soul, and sparks like fire in my soul, right? Dude, I love these, like unlocking other teams, enablement, right? I'm energized by enabling other people and teams. That's so good. Streamlining other processes, helping people. That's so good. I mean, That's awesome. Seems like y'all really like the being able to build something and see the data flowing. I like that. The builder, kind of like the builder mentality. I like that builder mentality. That's like the one of my favorite parts of data engineering as well, is like when you like see all of it like come together and you're like, wow, it feels like you made Frankenstein work, right? Because you're like, oh, I wrote all these queries and then they all came together and now we have a beautiful data set, right? And that's great. Yeah. Okay, yep. I totally agree, Krishnal, about that. Like that. There's like that kind of the long-term outlook. Yeah, Yomi, I agree that not having to obsess over pixels. Like I'm totally with you there. Like I do full stack development, and every time I get into CSS, I'm just like, ugh, I hate this. I hate this so much. Right? Every time CSS murders me every single time. I love that. I love that. Like this is awesome. All right, y'all. I totally agree. I think that those are some very good, solid reasons. Like, you know what surprises me? Like, something that really surprises me from all of this is that like nobody, not even one person said the money, right? No one said it. No one said it, and it's like I don't know. It's data engineers get paid pretty well. I feel like data engineers get paid pretty well, but I think that's freaking awesome that y'all like have more of that. It's more. Intrinsic, right? You're like, I like to build, I like to enable, I like to help. And it's not like I like to get paid, right? I like to make fat stacks of dollars or whatever, right? So that's awesome. I'm overpaid by a lot, like a lot. I can, oh my god, that's so good. That's too good. Yeah, I hope by the end of this, at the end of this bootcamp, all of you are overpaid, right? That's the whole goal of this, right? So, okay, awesome, everyone. Like, thanks for, coming up with a bunch of good reasons. Like, I think that, like, you really do want to focus on those reasons a lot because, data engineering can also test you and it can make you feel like you want to run away sometimes and you want to, like, not do this anymore. So, one of the things I'm curious about is, now I wanted y'all to drop into chat, like, what's the hardest part? Like, what about data engineering? Like, do you find very challenging or difficult? Yep, on call. Yeah, validating data, especially as a perfectionist, because you can't get it perfect. I remember that. Like, Julio, I'm going to tell a story about that in a second, about validating data as a perfectionist that I figured out. One is like, I think I told the story like in like week 2 or something, but I want to tell it again because it's a good story. Work-life balance with being on call, talking to stakeholders, and bring everyone on the same page. Multiple stakeholder bosses, on-call nights, troubling why job failed in the middle of the night, backfilling, lack of documentation. Yeah. Learn company internal knowledge that is not documented. Yeah, I hate that. I hate how like there's a freaking like all that tribal knowledge, right? You have all those people who like have all of this knowledge and it's just in their head and they haven't like written it down anywhere. Like and that's important to like get. Yeah, backfilling. We're actually I literally am talking about backfilling today. Like it's great. This is great. Like I nailed it. I nailed this presentation just based on what y'all are saying. So like I think that there's like kind of like three sort of pains that really are coming up here kind of over and over again, right? Part of it is like communication, like requests, like that's one piece of it, right? Which is like it's like I like to consider that almost like business on call. That's a way that I like to think of like ad hoc requests, especially like when people are like, oh, can you like go and build out this new pipeline for me? Can you just whip up this data real quick? And I'm like, is it an emergency? Like, oh, it is? Okay, then this is now an on call. It's a business on call, even though it's like development, right? It's not necessarily the same as like unblocking or fixing a pipeline. But that's going to be one bucket. I think another bucket here is going to be around on-call, like the actual on-call, like of just keeping your pipelines running. That's going to be another one that I think is important. And then the third one, I guess, is around like documentation and knowledge transfer and stuff like that. I think those are going to be your 3 buckets that really are the big ones, right? Data modeling with thousands of tables from entire business, without their internal system knowledge. Yeah, dude. Like, if you have a company that has 1,000 tables, dude, that's a lot of tables. Like, I mean, like the odds that you need 1,000 tables, like, even if you're like, I don't know, like, I feel like, at Airbnb, I feel there was like 300. And that was like all they needed. Obviously, there was like 300 like trusted tables in the middle, but then you have like the leafs. Obviously, there's like thousands of leafs, but you don't like. I mean, most people. I'm just talking about the master data that people should build everything off of, right? But obviously, like a lot of companies don't have their data stuff together quite as much as Airbnb. But okay, yeah, I mean, I agree with all the stuff. Tons of tables, a billion tools. Yeah, a billion tools. That one's like interesting. Like, I don't know, because you know what's interesting about that problem with a billion tools, like I don't know. Maybe this is coming from me from a place of privilege, working in big tech for most of my career. But like I don't know. Like I feel like for me, I've been using like Spark, Airflow, S3, and like those three. I've been using those three tools like for like 6 years, and like nothing new. Like that's about it. Yeah, Nitish, you had a question? They're just like, are they all about like Fivetran and stuff like that? Like no code, low code stuff. Like like the engineer inside of you just dies because you're like I want to write stuff better, but like this tool doesn't let me, right? All right, y'all. I want to do one last follow up here just to see what other things are. Like, what was y'all's favorite data type? I need to know. I need to know. Like, I know that's a very like strange question, but like, oh, dude, Joseph over here. Joseph with the date time as your favorite one, dude. Not date time with time zone. Not, oh, dude. I don't know about that date time column, dude. I like tuple. Tuple's a good one. Boolean. I like Boolean too because it's like very like it's as simple as you can go. You're like I like the 1 and the 0, right? I like the binary data types, right? Yeah, like varchar, so great. Like struct, string, yeah, string, varchar. That's so good. That's so good. I like all of those. Like I think for me personally, I like map actually the most. Like I like the like map string because that's just like so useful. You can essentially model whatever. Oh, season stats. Oh my gosh! Like you're like not just any struct, but this very specific struct. Oh man, that's so good. That's so good. All right, y'all. Great. I mean, I think that I learned a lot from y'all here, and I hope y'all learned a lot from each other and how this kind of data engineering world works. Like, I think it's important to remember just that like there are things that are painful that you want to like look into. Congrats on getting to the end of the day 1 lecture. If you're taking this class for credit, make sure to switch to the other tab so that you get credit for it. Okay, there's essentially 4 things here that I think are going to be your big signals at the highest level of we have tech debt or too much tech debt in data engineering. We have pipelines breaking, we have cloud bills, then we have large cloud bills that are maybe out of control cloud bills. We also have multiple sources of truth. It's another interesting tech debt problem. And then you have unclear data sets that aren't documented. So each one of these has their own kind of like remedies to kind of fix. We're going to go over kind of some interesting remedies that we can go over for each one of these buckets so that we can know how to maybe fix some of this stuff. Okay. Say you have a painful pipeline. You have a pipeline that's breaking, and say it's every on-call. So you have an on-call, and then it's like every Saturday and Sunday it breaks, and it ruins the on-call's weekend. And then it's like, then you just dread being on call because then you're like, I have to give up my weekend, and I don't want to do that because like a lot of times, like if you're on call and it's the weekend, and then you have to work on the weekend, and then you get no break, and then you have to go immediately into work after working on the weekend, you're like, data engineering is freaking me out right now, man. I don't want to do it. And so that's where troubleshooting these problematic children and these problem pipelines can be very important. So the only thing, I like this. The only thing better than optimized is deprecated. I love that saying. Because it's like that's how you get the most efficiency, right? Is like if you just delete the pipeline, you save the most in the cloud, right? If the pipeline doesn't exist. Obviously, that's not always the case of what you want, but so sometimes deprecated is the right play. I wanted to talk real quick about an example that I had at Netflix that was interesting. So when I was working at Netflix, I worked in detection, right? And so in detection, they had this like legacy system for detection that was based on, it was a batch processing legacy system. It was like an hourly batch processing legacy system. And it ran in, I mean, there was like, it was like a suite of like 50 pipelines that were all running to like detect anomalies in the cloud environment. And the security team was like, this isn't good because it detects anomalies an hour late. And we were like, yeah, that kind of makes sense. That makes sense why that's not good. And then like we were like, okay, we're gonna move some of them to streaming. We're gonna move whatever we can to streaming. And but then we realized that like even before we moved everything over to streaming, we recognized that they weren't even using the data anyways. So we were like, why are we paying this maintenance cost every single day on these like 50 plus pipelines for data that's not even being used, data that's not providing any value? Like, why are we even doing that? So uh like so what we did was we got everyone into a room and we were like, can we get rid of this? Do we even need this? Like, this is causing us a lot of headache. Do we even need to have these pipelines around anymore? And there was a lot of pushback because there was essentially the like what if we need to run a query, and then we talked with them and we're like, you haven't ran a query in the last 60 days, so that what if is like, maybe that's not like actually gonna happen. But obviously security is an interesting space, right? Because it's like you want the you only need the data when like something bad happens, right? So it's like a lot of the times like maybe you don't need the data. But it's kind of the idea here. So uh that was something that we ended up doing there. We actually were able to convince them. It took like, it's like a 6 month process of convincing them to delete these pipelines, but we were able to do it, and that made our lives a lot better because then our the maintenance burden for the on call dropped. Like, it went from like on call being terrible to on call like almost being nothing. And so a lot of times that can be the case. And there was like, because the thing was is those pipelines were already as optimized as they could be. There was nothing else we could do to make those pipelines better. It was just that there was a lot of them and that like they were doing a lot of work, and that like once like you kind of have the tragedy, not tragedy commons, you have the like Murphy's law or something like that, like where once you have enough of something, you're guaranteed to have one bad of that, right? It's like once you have a room of enough people, right, you're guaranteed to have at least one asshole, like just guaranteed, right? Because like that's just how people work. Or there's a certain percentage, even if it's like 1% or 0.5%. Like once you have enough people, you're guaranteed that there's going to be at least one asshole in that room. And so same perspective here, right? Where it's like, okay, well, like maybe we shouldn't try to spend all of our time and effort optimizing these pipelines, but we should actually just delete them. And in that case, it was actually the right call. And so, like, that's one of the things that you got to remember about, especially when you inherit pipelines, and they weren't necessarily pipelines that you built yourself, but you inherit a suite of pipelines from another team or another engineer. Like, question the value and actually ask yourself, like, is this worth being on the on-call rotation? Is this something that should actually be troubleshooted over the weekend? Because maybe it's not, and maybe it shouldn't even exist. And if that's the case, then deleting it is great because then your on call becomes way easier. And like, I'm sure some of y'all like are like, Zach, that sounds like kind of like too good to be true, or like, because I think all of us have had nightmares as data engineers where we were like, you know, our life would be a lot easier if we just deleted all the pipelines, and then there would be no data, and then our lives would be solved, and then we wouldn't have to do anything, and then all the buzzing in our head and all the anxiety in our hearts would go away. And but like in some cases, I've actually had a couple cases in my career where that was the call. So is there anything that can be done with this, right? Besides, you know, deleting it, you can migrate to new technologies. It's great. You can maybe implement better data modeling, so you have fewer pipelines that are running because you have more robust data modeling, where like you don't have to have like duplicative models, and you kind of have like one model or one pipeline that produces a more robust model. Because then it's like, if you can take, say you have a suite of 100 pipelines and there's a 1% chance that things break, then that means that something's going to break every day. But if you have 10 pipelines and there's a 1% chance that things are going to break, that means that things are going to break like a couple times a month. And big difference. Very big difference. Like especially if you can keep the failure rate the same and you can make the modeling better, then like the consistency at which your things actually fail, because things are going to fail, pipelines fail, like, and like nothing's perfect, and don't ever expect to write a pipeline that's never going to fail. Like it's going to fail, and it's just all about like the frequency and the rate and all that stuff that you want to think about, right? Other things that you might want to consider when you have a painful pipeline is, can you bucket the table? That can sometimes help quite a bit. I'll talk more about some examples that I've had in my career where bucketing was like a silver bullet. And the other one is sampling. Sampling's great. A lot of times, because a lot of times you just need directionality. You don't need every single record. And if you can just like get a 1% sample, then you just did a 100x reduction in the complexity of that pipeline with like one line of code. And sometimes that's the solution. Just don't process all the data. Like, I know these solutions seem like in some ways they're not like tackling the scale. They don't sound sophisticated, but they're smart. That's the part of it that's great, is that like if you have like a bunch of pipelines that are processing a lot of data and they're not providing that much value and they're causing you a lot of headache, like this is a beautiful path forward that can actually work, and especially in terms of maintenance. And I've seen this work many times, and definitely remember that deleting the pipeline could potentially be a tool in your tool belt. You don't have to just optimize it. So that's a beautiful path forward. I love it. So I'm sure some of y'all have upgraded from Hive to Spark. That's probably a common thing that y'all have done. Uh, I've seen massive gains here, but there's also like, it's interesting because this promise is not linear or not uniform, right? Because a lot of times, like some people are like, oh, if you migrate from Hive to Spark, and you'll see a massive performance gain, and that's only in the case of very specific types of pipelines, and they have to like essentially use like a very high cardinality group by or a high cardinality join. They have one of those two keywords in your SQL, then migrating from Hive to Spark, you're going to see a massive, massive gain, like probably between 50 to 90% more efficient. And like that's awesome. I think one of the things here that some data engineers make a mistake about is they promise more because they think that that's going to be the case for every pipeline. But some pipelines you're going to see flat. Some pipelines are going to be only 5 or 10% more efficient. And then, but there are some edges where like it's really, really a lot more efficient, where the being it, because Spark versus Hive are very interesting, because Hive does everything like on disk. It doesn't have any, it doesn't use RAM at all. Like, blows my mind that that's what we did for so many years. We're just gonna write all our data to disk forever. And but in the same vein though, because Hive does everything on disk, it's very resilient. And like a lot, like Hive might be really slow because it does everything on disk, but it's definitely gonna finish. Whereas Spark might actually fail. Like, that's one of the other things that I noticed when I did some Hive to Spark migrations, is Spark was more efficient but less reliable. Where like Spark is actually more prone to out of memory exceptions and more prone to skew than Hive is. So when you do these migrations, sometimes like it's a trade-off. It's not just like you're getting, it's not like an upgrade. It's like you're getting a certain set of traits, but you're losing other set of traits. And for the most part, the trade-off is worth it, and that's why people do the migration. But that's what I'm saying, is that like Hive pipelines are technically more reliable. They're more reliable but less efficient. So that's a thing to remember. And the main reason for that is because they do all the calculations on disk, whereas Spark uses RAM. And that can be one great way to improve the kind of efficiency of your pipeline, and the landing time and all sorts of other things like that. But not necessarily the reliability, right? Because the reliability is the one side that like Hive and Spark are like Hive is actually has a slight edge. So that's one thing you can do. Upgrade the technology. Another option here, right, is maybe you want to move to like streaming, or you want to move the pipeline to streaming. Obviously, that should be something that should be taken very, like, you should be thinking through that problem very a lot. Like, definitely, like, don't just bring in Flink. Like you should only be bringing in Flink after like you've really really thought about it, and that's really the only thing that you should do. All right, it's not necessarily like an upgrade problem. That's more of like a I need to solve a new use case problem. But in some cases, streaming can actually be more reliable because of the fact that it's just processing data as it comes in, as opposed to processing some big batch of data. And then that can make it so that the memory footprint of the job can actually be more consistent. And you don't have these big spikes in the memory footprint. And because when you have a job that has big spikes in the memory footprint, that's when you have jobs that are more likely to run out of memory. And especially like in Spark, right, there is that hard limit, right? You have that 16 gigabytes, right, where it's like if you have a partition that ends up being bigger than 16 gigabytes for whatever reason, because of skew or whatever other reason, then it's going to be more unreliable than a streaming job that potentially won't have that same spike because of the fact that it processes the data as it comes in. So that can be another potential thing that could increase the reliability of your pipelines. So technology upgrades, pretty cool. So sampling, I love sampling. I want to talk a little bit about an example, kind of war story from my time at Netflix. So one of the things I worked on at Netflix was how to create a metric that measured the amount of incremental AWS cost from an A/B test. So it's like, say you have two like a test and control group in an A/B test, and one of them causes the app to make more requests to the server, and then that server will send more data down. But maybe though, like it's 10% more requests, so then the server load is 10% more or something like that. And so like the way that I was looking at that originally was like, okay, I'm just going to look at all the network requests that that Netflix receives, and it's like that's a very big data set. That data set is hundreds of terabytes an hour, and the metric that we were like and if you're processing hundreds of terabytes an hour, that's millions and millions of dollars a year in cost, like in actual cost to the company. So, and our metric that we were making was probably not going to save that much money. So like we realized that like, okay, like there's an ROI here where it's like we need a sample, we need to like cut the data down, and maybe only we ended up using like I think less than 1%. And since we were able to cut down the volume, and because we only need the directionality of the sampling, or of the data, not the whole like data set for auditing, and so that's a good way to do it. Before you set up sampling, though, make sure that you don't just like just set up whatever sample thing you want to do. This is something where like you do want to consult a data scientist about the data shape, so that like because it's very important to get a random sample. But for example, here is another thing to think about with like requests. I think this is a beautiful example where like I think as data engineers, this isn't something that we think about that much. But like, okay, there's two ways that you could sample the requests, right? Where it's like you could take a small percentage of all the requests and just do randomly take a percentage of all the requests, or you can take all the requests for a small percentage of users. And then you get the whole flow for every user, but you only take a small number of users. Or do you just take a small number of all the requests across the board? And those are you could get the same percent, you could get the same like reduction, but it's all about like what rows you pick and what rows you filter out. And that makes a very big difference on the data set itself and like what you're trying to solve for. Like, for example, in this case, the better solution here was to pick users and get the full request history for individual users, not filter to like random requests across the board, because then you get the full kind of makeup of like the whole like request flow for each user, and that's a better aggregation model than like in this other case where it's like you have like one request for this user, two requests for this user, and it's like kind of like you don't have their full history. So like the analytical capabilities of that way of sampling versus the other way of sampling is significantly different. So that's where like don't just like be like because it's easy to sample, very very easy to sample, like it's a one liner to put that into sampling, but don't don't do that. Like make sure to ask a data scientist. Like that's my main point there. Unless you are amazing at statistics and you already have the data science skills, then maybe do it yourself. But I know I don't. That's one of the things that I recognize that I want to defer to a data scientist about, because that will make the whole process a lot better. So Remember, sampling is another beautiful tool in your tool belt if your pipelines become more unreliable and you don't need the full data set. Okay, but like, when should you not sample? I think this is another important question. There's a good example here of like, if you need the entire data set for auditing purposes or whatever, then sampling is not going to work because you might be looking for a needle in a haystack, and if you sample, then the needle is gone, and you're not going to find all the needles that you are looking for. So audit purposes, nope, nope, nope. Okay, so that's sampling. Audits don't work. Go to the next one. Bucketing. Bucketing is very important. I'm going to give a couple examples of when I used bucketing in my career that were just mind-boggling how good they were, right? So, big thing with bucketing, right, is so when you have a join, right? So if you imagine you have a join of two data sets, you have this big thing called shuffle, right? Where you can imagine you have like the left and right side of the joins, and then how it works is that join key gets hashed into a number, and then that number gets moduloed, like, which is like you divide and you take the remainder, and then that is the partition that row gets assigned to. And mostly this is done with like the default modulo in Spark is 200 because you want to have 200 partitions, and then that's how it works. The problem with a lot of this stuff is that whole process of slicing all the data up and moving it around and then moving it across and then matching it up is very, very expensive. That shuffle operation is very expensive. So what you can do instead is when you write the data sets, the left and right side, say they both have user ID, they're joining on user ID, then you can write the left and right side data sets to their own partitions, essentially. So instead of writing like one big Parquet file, you write like maybe 1,024 smaller Parquet files that do that modulo operation already, so that you have them in 1,024 files, and then the right side is also in 1,024 files. So when you do the join, you just match up the files, right? And then the files just match up. And then you don't have to do all this crazy. There's no shuffle. Shuffle doesn't exist if you bucket. So, and that is I highly recommend listening to the speaker series with Sundar. He's a senior staff data engineer at Apple, and he talks a lot more in detail about how he uses bucketing to solve hyperscale problems at Apple at the petabyte scale. So bucketing is one of the most important optimization techniques, especially for the highest volumes of data, because once you have massive volumes of data, that join where it does that shuffle technique, that shuffle is broken. Like once you're over like 10 terabytes, shuffle just breaks down and becomes very, very, very expensive. So that's where you can get a massive performance gain if you just write both of the left and right side of the join to bucketed tables, because then you can do the join without shuffle and it's very performant. And so when I was at Facebook, this is a big thing I was doing in notifications, was I had the same problem where like the notifications table, I had like this. So one of the tables was called notif data features, which was like it was like a machine learning table that had, for every notification, it had the like a vector of features of all the different features of that notification, like when it should be sent, what content type it was, the probability that someone was going to click on it, the probability that someone was going to ignore it, like all sorts of different like a big vector of like hundreds and hundreds and hundreds of things, right? And then on the other side, you have the actual events. You have they clicked on it, they sent it, right? Because you need to merge these two data sets, because then you have the features and the facts. And if you merge them together, then you can actually train the model again, because then you're like, oh, we predicted that there was a 90% chance that they click on it, and then they didn't. So that's going to maybe drop the next time they generate a notification that's like that notification. It's going to drop it a little bit because that's going to retrain it. But anyways, that join was actually at the notification level, right? Because you're joining the notification features and the notification facts, and you join them together. And then like that join was very, very large. And so what I did in that case was you join on notification and on user. And if you do that, then and it was bucketed on user. So then you just line up all the files that are based on the user ID and bucket it. And then you can join those together. And then that removes all the shuffling that was in there before, and then it made that job go from taking, so before that job was taking up 25% of all of notifications compute, and then after I made that optimization, it took up 4%. So we got a massive increase in efficiency, and also a ton of compute back, and it made it so our namespace was actually like working again. It wasn't just like on fire all the time. And so that was a big win that we were able to do with bucketing. So I highly recommend just checking out bucketing as well. Like, we're gonna do a little bit of bucketing next week in the Spark week, if yeah, because you're all in the infrastructure, so y'all will definitely be in the Spark week. So it's good stuff. Like, I definitely have used it a lot. I've used it at Netflix as well, in some other very hyperscale use cases. So that's kind of like another big thing that I would recommend looking into. There are drawbacks, though. I think that I want to talk a little bit about how, like, it's not like because just because it solves these hyperscale problems, like, I'm not advocating that every table be bucketed. And one of the main reasons for that is that, say you bucket everything to 1,024 files, and it's like a small table. Then when you read it, it has to read in 1,024 files, and there's like opening and reading that many files is slow. And like, it's worth it when there's a lot of data, but like, if it's not very much data, then the cost of like opening and reading all of those files is higher and more of a pain in the ass than if you just don't bucket. So that's why, like, this is something that is kind of more reserved, like, for tables that are at least over a terabyte. Like, I would not recommend bucketing on anything under a terabyte. So that's that, because if it's under a terabyte, you might as well just shuffle, and you're gonna get the, like, probably a better performance characteristics. So that's bucketing. Bucketing can save your life. Okay, so another big thing that can happen, another big signal for tech debt, right, is large cloud bills. So one of the things to remember about the cloud is there's essentially three places that you pay. You pay in IO, you pay in compute, and you pay in storage. Those are the three places that you pay. With IO usually being the biggest one. And because the main reason why IO is the biggest one is compute is generally fixed, right? Because you like rent your computers on like a fixed basis. And then like, you either have enough or you don't have enough. And then if you don't have enough, you need to buy more computers, and great. But like, if you don't have enough, or if you have enough, then like, you're going to pay the same amount anyways. And then storage is just generally really cheap, like especially in comparison to IO and compute. And one of the ways you can think about that is, okay, moving data around and moving it from point A to point B is going to be one of the most expensive operations that you're going to have in your cloud bill. This is where, like, this is probably the one argument that I have for the signal table pattern. If y'all remember from week 3, we talked about the difference between write, audit, publish, and the signal table pattern. And this is going to be and this is Facebook's rationale as well of why they use signal table over the write, audit, publish, is because write, audit, publish actually does a partition exchange. So that means that every time that you write a table with write, audit, publish, you actually essentially do 2 times. You do IO twice, right? You do IO into staging, and then IO from staging to prod, right? And so that's where you pay your IO cost twice, which is pricey. It's not cheap. Like, it's actually it's like the most expensive part of your cloud bill. So that's why it's not as cut and dry of like, you should use write, audit, publish, or you should use signal table, because of the fact that IO is just so expensive. And that was one of the things that I noticed, like, because when I was working at Airbnb, and I found some massive wins in storage and compute for Airbnb when I was like computing the savings that I saved for them. It was like, essentially it was like, okay, I was able to save like 5% of all the savings was in storage, and then 10% was in compute, and then 85% was in IO. And obviously this depends on the pipeline as well, because in that case, the reason why that was the case for me is because the pipeline I was working on had a lot of downstream usage. So if I was able to make the the storage footprint of a table that has a lot of other pipelines reading it, then that's actually where you get the big win, the big savings is where they read in that smaller table every day, and as opposed to reading in a bigger table every day, and then the savings you get is multiplied by the number of downstream pipelines. And that's why you get a massive IO win, because you scale based on the number of other pipelines that are reading from your data tables. And so that's where that's why IO can be so massive as like a win. But obviously, like if you're in the case where you're at the bottom of the like data engineering tree, where like your pipeline is producing a data set that is like visualized in a dashboard, and it's not master data, but it's like more of that final like metric aggregation layer, then IO is not going to be your biggest cost. It's going to be compute, probably. It's going to be close between compute and storage. Probably compute, and then storage would be your highest costs, because you don't have that multiplicative effect of all those other pipelines reading from your pipeline. So cloud bills. There's a lot more we're going to talk about here with cloud bills, because I think this is a big area where you can have a big win, both in terms of efficiency and in terms of maintenance. Okay, so let's talk about why too much IO can happen. Okay, so obviously the first one is duplicative data models, where you have like when I was at Airbnb, there was when I first started there was 7 different definitions for availability. Like, is available, there was 7 different ways that people define that, and it's like, why? Like, why are we doing that? Like, and I mean, it's like that pain is actually that pain is not just an IO cost, right? That pain is also in communication overhead, where it's like I say available, you say available, but we mean 2 different things. And so like you also like in some ways that's even the bigger cost is on the communication overhead, because employee time is just so expensive. So like that's but like IO cost as well, because it's like, why do we have 5 different tables for this when we should have 1? And then those pipelines write every day, and they are generating these tables every day. And so that duplicative data models, not enough robust data modeling, big place where you eat in IO. You have inefficient pipelines. So imagine if you were doing like the monthly active user pipeline, and what you do is you just read in the last 30 days of fact data, and you do it that way, and you make Zach sad because like I taught you better than that, and like I taught you to use cumulative table design, and because you don't need to scan 30 days of data to process this every day. You can scan 1 day of data and then the historical, and then 1 day of data to calculate monthly active users. And so that's another place, because in those cases, if you're scanning 30 days of data every day, that's a lot of IO, right? You're reading in 30 partitions every day when you could be reading in 1. Another big place where you can eat a ton of IO cost, and I'm always like so painful. Ow. You also have excessive backfills, where maybe you are trying to backfill a data set and like you're kind of hasty about it, and you didn't validate all of your pipeline code yet, and you didn't like really thoroughly validate it. This is where Airbnb's Midas program, like they try to avoid these IO costs by, they say first backfill 1 month of data and then validate that. And then if that looks good, that 1 month of data looks good, then backfill the whole history of the data set. Because then you don't pay these IO costs over and over and over again if there's a bug. Because that's happened to me before. I've been there. I've made this mistake myself many times. Like probably at least 3 or 4 times in my career, where like I've backfilled 7 years of data, and then the analyst comes back to me and is like, these numbers don't add up. And then I'm like, wow, like I just gave Jeff Bezos like $5,000. I'm sorry, Jeff. Or like, you're welcome, Jeff. And I'm sorry, Brian Chesky or Reed Hastings or Mark Zuckerberg. Or I guess Mark Zuckerberg he owns his own infra, so like it's different there. But at Netflix and Airbnb, they both like give Jeff Bezos money. So anyways, backfills. It's another way that you want to be careful. Make sure to follow backfill best practices, and to be very confident that the data that you're going to backfill is going to be correct, so that you don't just do it all over again, because backfills are very expensive, because it's like running all of production for 7 years. Like that's like a lot if you're depending on how much history you're trying to backfill. Then you have not sampling. That's the case where like you feel like you have to use the entire data set when you don't actually have to use all the entire data set. You can do it without all of it. That's another kind of common problem I've seen. Also, not subpartitioning correctly. So subpartitions can be great because especially if your data table has another low cardinality column where you can that like you can split the data up in a more a cleaner way. We're going to talk about that. I have another slide here because predicate pushdown can be amazing in that case because if you have a subpartition, what it allows you to do is it allows you to avoid reading in a big chunk of data that you don't need to read in, and it just ignores that folder because it gives you another layer of folders, and it says, oh, our query doesn't want that folder because it's filtering it out, and we don't even have to read in the data, we can just ignore it. And so that's where subpartitioning can be very, very powerful in avoiding large cloud bills. There is some trade-offs there, and like I think that there are definitely cases where I've seen subpartitions used incorrectly as well, but that's generally speaking, this is how I would imagine things would work with large cloud bills. Those are going to be your big ways that big symptoms or big causes of large cloud bills that you can probably fix. Let's talk a little bit about why subpartitions work. So imagine you have a table here. We're calling this table notifications. And then this table has three partitions, or it has a subpartition on channel. So it has a partition on date and a partition on channel. And you'll see, okay, we have three folders here. We have a date. We have one for January 1st, January 1st, January 1st for email, SMS, and push. And one of the things you'll see is we have a query down here, select star from notifications, where date is January 1st and channel equals SMS. So you'll see when this query runs in Spark, it will skip this folder and it will not read in this data set at all. So you don't pay the IO cost where like, if this wasn't subpartitioned, right, and say we were only partitioned on date, then what would happen is we would read in all three of these data sets and then throw all of them away that didn't match SMS. And then that would be extra IO cost that we wouldn't want to pay. This is a great way to avoid that IO cost by like just immediately filtering it out because we know that none of the data in this folder is going to be valid. And so that is definitely one of the powerful things that you can do with subpartitioning, especially if you have a subpartition that is kind of low cardinality. Like I generally think of like if you have a subpartition, it should be like it's similar to enums. Remember how we were talking about enums before, where enums are like it should be like 30 or less. If you have like if it's like where you have the number of unique values is like 30 or less, and usually it's like 5 or less, but there are some edges where there's a little bit more. But generally speaking, it should be like 30 or less values. This is where like country is always the one that's like some people are like, yeah, we should subpartition on country, and it's like, nah, dude, don't do it. Like country is gonna be annoying. Because if you do country, then you're gonna have to have like 200 tasks, and that's super annoying. So you want it to be more of a low cardinality field that you and one that people use in their filters a lot, right? Because one of the things that was really powerful about this subpartition in notifications is one of these notifications types is a lot bigger than the others, right? Push is 2 orders of magnitude bigger than SMS. So it's like if you didn't subpartition and you wanted to run a query that looked at SMS, you would be reading in all the data and then throwing 99% of it away and paying that IO cost because you read it in. You read it off of S3 and just threw it away and just wasted it, right? And that's where subpartitioning can be very powerful in giving you more of an IO efficiency gain that I highly recommend looking into, especially if you have any big fact data. That's where you're going to see some really big gains here. So let's talk a little bit about how these things are connected, actually, because I/O, compute, and storage are not independent. Where like if you have bigger tables that are stored in bigger places and you read in more data, like you're gonna have more I/O, and so storage and I/O are obviously connected, and compute is also connected to these two, right? So like what I was saying before, large I/O and compute are connected a lot because if you're scanning too much data, you're going to be reading in a lot more data, and then you're going to be running a lot more. That's going to tie up your Spark executors for a longer period of time because that I/O time is just like expensive. So you want to make sure that you are not doing that. Sampling is another great option here. Besides cumulative tables, sampling, predicate pushdown, all that stuff. Also, make sure that you're like in your UDFs, you don't have any n squared algorithms. In that case, that's where you have like loops inside of loops. If you have nested loops in your algorithms, you want to like make sure to kind of avoid those. So there are some small edge cases where that's the only way to solve the problem, but like 99 times out of 100 that I've seen a nested loop in production, it's tech debt. It's not like, oh yeah, that guy just had the best option. He knew exactly what he was doing and he thought through everything. No, he was just trying to solve the problem in the quickest way he thought of. So IO and storage are correlated because if you're not leveraging Parquet, the file format the best, then you're going to get a lot more IO costs because your storage tables are not compressed enough. And if you can compress your data tables with Parquet, then your IO is less because when you read in the data, it's compressed, and then it only becomes uncompressed when you are already you're in the executor and you're already on the machine. So then you don't have to worry about you don't have to worry about the IO cost at that point because the IO is already done and because it's compressed already. And then obviously the other one is duplicative data models, just like what I said earlier, where it's like if you have 7 different definitions for the same thing, you're going to get a lot of extra IO, a lot of extra storage, a lot of extras. It's a lot of so that's why like data modeling is so important, right? And so critical. Okay, now this is one of the things that I find a little bit more near and dear to my heart because I think this is probably the most impactful work that you can do as a data engineer. And it makes your job easier and it makes things more efficient and the maintenance is better. It's like you win in every single way and there's no way that you lose. That's the part that is so crazy about solving this problem here. And like so if you can solve these problems, this is where you're gonna really find a lot of impact as a data engineer. And this is like solving these problems is also like where I got really good performance reviews at Airbnb and also all sorts of stuff like that as well. And so let's dig a little bit into this. So it's very common, especially as an organization gets bigger and bigger and they have more and more needs for data, that they don't have enough data engineers or they don't have enough data infrastructure. And like what ends up happening is like different aspects of the company are like, well, I need this data set and I just need it as quickly as I can get it, right? And then they don't really care as much about the quality and they don't really care as much about like if other people have already created it. They might search real quick to see, and then if it's there, great. If not, they'll go make it themselves and then they'll keep doing that. So this work is complicated because of the fact that one, when people do these multiple sources and they have multiple pipelines that are producing the same thing, they might have different variations of the same definition. So usually that means that you have to convince somebody that their definition is wrong because, or maybe not wrong, but at least kind of not correct. And that is going to can be tricky sometimes because sometimes even people who are not data engineers are kind of married to the data that they created. And they're like, no, this is the most correct way to do it. And so you want to get all these stakeholders in a room. So like, for example, for me, when I was like trying to solve this, like many different definitions of availability at Airbnb, like I had to get so many people in rooms and just talk it out and see like how we could solve this problem and going forward. And like both like, and the thing that was crazy about the way that I solved that problem was that we didn't end up picking any of the ones that already existed. We created a new definition and then everyone agreed on that definition because they were like, yeah, that's the most correct definition. So sometimes that's the other thing about these multiple sources of truth is that they can all be wrong or they can all have problems as well. And that like there's actually another path forward that might be the most correct or the most efficient or the best. And so just because there's multiple sources of truth doesn't necessarily mean that one of them is, quote unquote, the truth. That there's actually potentially room for improvements on all of them. And so a big thing to look at here is you want to document all the sources of truth that you can find. This is a big thing. I remember I had this spreadsheet at Airbnb that had it had like 30 or 40 tables in it. And like, I was like, if we can just consolidate, all of these tables can go away and we don't need any of them. And we can go from 40 tables to 4 and it would be better. It'd be a lot better. And that was the vision I sold my manager on. And I'm like, it's going to be so much better. And you need to document these things. It's tricky though, because of the fact that like one, people can name a table whatever they want. So it can be tricky to even necessarily find all the sources of truth. That's why, like, generally speaking, you don't find all the sources of truth via code search or via like grep or however technical way you want to do it. That can be a good way to get a good like fundamental start, but like you really do want to talk with all the relevant business people, all the relevant people who like in all the areas of the business that might be using this data, because then you could uncover some really funky table names, things that you didn't even consider. Someone might have named their table QQXXLLL underscore W, and they're like, "Yep, that's availability," and it's like, "Okay, bro, okay, it's availability, I guess, right?" And anyways, you can't just rely on like searching the code base to find these tables. You need to talk conversations. It's important. And these conversations are also important anyways, because it can help you understand like why they're using this data, and also understanding maybe the pain that they're having with this data, or the lack of completeness, or the difficulty, or like all sorts of other things that you also want to pick up, right? Where like if you're part of the combined track, yesterday we were talking a lot about being a product manager, and this is a very relevant place to be here, where like if you're building a pipeline, you want to be a data product manager, where like you want to understand end to end how to delight your customers, where a big part of that is completeness, another part is quality, another part is just refresh, freshness, quality, completeness, ease of use. All of those things are very important. And then also, if you take a pipeline off of someone's plate, they'll love you forever, because then they're like, wow, I don't have to manage this beast anymore, and you will just manage it all for me. Like, thank you. So like that's why you also get a lot of claps and a lot of kudos for doing this as well, because like in my case at Airbnb, there was like, okay, there was 7 different pipelines at least of, you know, generating different availability definitions, and then we turned it into one that we owned, and then it was like, okay, all those other pipelines that people were using we don't need anymore. And so that was another way to get a lot of kudos, a lot of respect, right? Is you're deleting work for people and deleting maintenance for other people. It can be tricky because sometimes it's like you're deleting maintenance for them, but you're putting more maintenance on yourself. So you want to like have a good balance of all that stuff. Obviously, you don't want to try to be a superhero. And then after you have all the needs and you have taken in all the pain and you've documented all of the discrepancies and all of the different sources of truth, that's when you want to build a new spec. And you want to build out the spec of the new pipeline that you want to build, that's going to consolidate all of these things and be the new path forward, that then you can talk to all the stakeholders about and be like, this is what we're going to go to. We're going to migrate to this. It's going to save you all this pain. Can you agree to it? And you want them to agree to it before you build the spec, or before you start writing the code, because they might not agree to it. And like, if they don't agree to it, then the problem is then like, if they don't migrate, then a lot of your work is for nothing, because then they're still going to be using their own other definition, and then like all of that hard work of consolidating definitions is not like, it's just dead. So it's all about getting that stakeholder buy-in, making sure that everyone's on the same page. Most of the time it's easy, sometimes it's a little bit harder, but most of the time people are like grateful that you're doing it. So those are the 3 steps, like, and a lot of that's a conversational thing, not very technical actually. It's very human, very empathetic. Very product managery, right? Remember, I was saying, you know, talk with all of the stakeholders, code search for similar names, like, you know, you might want to grep for availability or something like that. And then you can also like potentially, if your company's really ahead of the game, they might have lineage. So then you can like go up to the source data, because a lot of times, even if you have different definitions of something, they all read from the same source, or at least some of the same sources. So then you can find like the most raw log data, or the most raw like database snapshots, and those tables are gonna like the downstream of those tables are gonna be the definition tables that you're looking for. And that can be another way to find that stuff. Not very many companies have lineage, though. Lineage is like kind of a new thing. I think that that's going to be in the future. I think that that's like going to be a good thing. That's one of the things that, you know, have you heard of Microsoft Fabric? I've heard that Fabric gives you that like out of the box. So if you just like use Fabric, then you get lineage for everything. And like That's cool. I like Lineage. I think that like being able to see where data comes from is very powerful, and it allows you to do a lot of this good work as you kind of go forward with stuff. So definitely do that. Okay. Another thing that you want to do when you're like consolidating all these sources of truth is understanding like how it got here, because there's more problems here than just the fact that there's 7 data tables. Like there's other problems here that are also important to talk about and also important to bring up. For example, one of the things that can happen in a lot of these cases is you can have organizational problems where what actually happens, why there's multiple sources of truth, is one team doesn't trust another team to deliver, and so they just go and build it themselves. And it's like, why is that the solution, right? And it's like when it, like that's where trust is super important, where you need to have trust between teams. Otherwise, like you're gonna have you're gonna have tech debt like this come up all the time. You can have an ownership problem as well. Like, for example, the team that should own this doesn't have the bandwidth to own it. So another team's like, okay, fine, we have a little bit of spare bandwidth, so we're going to take it on. And that can be another kind of problem. But then they aren't the right team to own it because they actually don't have enough of the business domain to actually do a good job. So that's like usually that's more of like a staffing problem where they should probably move one engineer to the other team so that then they can own that data set. Which is very hard to do, by the way. Then you have technical. Technical would be like, okay, the team that should own this doesn't have the technical skills to own it, and then one of the teams that we have does have the technical skills. A lot of these are a combination of organizational and ownership and technical, right? Technical and skills are the same way. And obviously there's going to be a long tail of other reasons why we have duplicative data sets potentially coming up. But the whole thing about this and why you need to have these conversations, especially if you're like going to become a data leader, is if you can solve the organizational problem, if you can solve the trust problem and the ownership problem, then you stop the bleeding. You stop this problem from proliferating. And then you can get people to trust each other more. And then you can get more consolidated data sets that way. And then less maintenance, more efficient. Awesome, right? It's really good. And then like another thing that's super important is like working with these stakeholders to understand what the ownership model should look like, and also like how changes should be incorporated. Like if the model does need updates later on, like how who's going to drive that and who's going to build that out, right? And really hammering that down so that people in these other teams can trust that this data set will not just serve them after it's migrated, but that it will serve them in the future as well. And that could be another great way to build trust and to build just to build a lot of like rapport and to make people really like you as well, because you're taking something off of their plate and also guaranteeing to them that it will be managed in the future as well. That's awesome. That's like you're taking work from them immediately and future work. So like that's a lot of love, you know? It's a lot of love. So remember to spread the love around. I love specs. Pipeline specs are so great, right? And that's what I was saying earlier. Got to build the spec, get all the needs, get everyone to sign off, and then because once they sign off and you have like a signature from them, or you have like they said this was good, then that is like when it comes time for them to actually move and migrate their downstream pipelines, like you can kind of bully them into doing it because you're like, yo, dude, you said you were going to do it. And because migrations are so painful, they're always so painful, and like having a document like this could be very helpful in getting people to actually do it. Let's talk about a little bit about the different models for fixing tech debt, of like kind of the team ways of fixing tech debt that I've seen. These are essentially the 3 that I've seen, where you have the first one is called like fix as you go. It's also called like Boy Scouting. It's also called like a bunch of things like that. But it's like mostly like when you're shipping new features, fix the tech debt as you go. And it's an interesting model. We're going to talk about the pros and cons here in a second. Then you have like allocate a portion of time each quarter. So a lot of times, this is what Airbnb did, was the second one. It's called the Tech Excellence Week, which was the last week of the quarter. The last week of every quarter, we just did not work on new features. We only worked on cleaning up tech debt. And amazing, by the way. I love it. Loved it so much. And then the The last one, this is the way that it worked at Netflix, was instead you have the on-call person focus on tech debt because they get slapped in the face every day with the tech debt because of they have to fix the on-call problems and to deal with the maintenance themselves. So then we're like, okay, on-call person, just if you're dealing with the maintenance already and you're unblocking things, why don't you not just unblock but also fix things? So you get kind of both in that way. But these three methods have their kind of pros and cons. All right. Obviously, fix as you go. The biggest pro here is like it's not very structured and like you can there isn't much incremental burden. Like you're not taking away from very much else. I think the con here for this model is that like it sounds too good to be true a little bit, where it's like, oh yeah, as you're coding, just fix the tech debt. It's almost like as you're shipping features, fix the tech debt, right? It's like almost like as you're flying the plane, fix the plane. And it's like, I don't know about that, fam. I don't know if that's like an actual viable model or not. If it is, cool. If not, like, I don't know. I haven't ever seen it work in practice. All right. I mean, that's what Facebook was all about, and Facebook freaking was a mess. In terms of tech debt, Facebook was by far the biggest of the messes. So then you have the allocate dedicated time each quarter, right? You actually fix things in big bursts. It's great. One of the problems with this, though, I've found is that like people essentially, if you do have that dedicated time at the end of the quarter, you don't have that as you go fixes, and a lot of times you get like you get this like tech debt line, and then it's like cliff, and then build up and cliff. Right, and it's like a crazy and like so at the end of the second to the last week of the quarter, there's a lot more tech debt in the code base, right? And then like and you're not like it's almost like saying like, oh, I'm gonna save up all my teeth brushing and I'm just gonna brush one time for 90 minutes at the end of the quarter. And like, I mean, I don't know if that's how it actually works, but that's generally speaking, that's how I've seen it work. The other minus here is then people during that week, they don't have time to help stakeholders or to ship other features or other things like that. It comes at a pretty heavy cost for that week. I mean, you spend a month a year working just on tech debt, which is a significant amount of time that you could be using to spend other things, kind of like the opportunity cost. Having the on-call person do tech debt, the cool thing about that is that they are very aware of what the most urgent tech debt things are because those things are slapping them in the face because they're like, wow, this is failing, everything's on fire. And then they have to get their fire extinguisher out and then they like try to fix stuff, right? I don't know. Like one of the things that I've noticed with this model is that like some people don't actually do it. I think that's one of the things I like about the dedicated week as opposed to doing on-call person do tech debt is the dedicated week is like everybody is doing tech debt that week. So you can kind of like, there's this expectation that you all ship something, that you all clean stuff up and that like you're going to hold each other accountable. I found with when you say the on-call person needs to do tech debt, that they don't actually do it. That like, I would say only like half the people actually do it. And that was actually something that frustrated me a lot when I worked at Netflix because I was like, yo, dude, like if this is our model, like why aren't we cleaning stuff up? Why aren't you actually dedicating the time to that? And like a lot of times it would be they would want to spend that time working on new features or working on other stuff, right? And working on the things that are going to like get them promoted. Because a lot of times tech debt stuff is not as visible. And so it gets deprioritized. And that's why I really do like the dedicated time each quarter. Because then it's like, well, it's not as visible, but we're all going to work on it together at the same time. And then it's like, because it's kind of a team effort in that way, like it takes a village to, tackle tech debt. And so those are the three models. Obviously, I biased y'all into saying which one I like the most, but I also think that the one that I like the most is the heaviest. It's the one that takes up the most time. It's the one that, the way I think about it is it's the one that really takes it seriously, though. It doesn't just treat it like a secondary priority or like something that I'll get around to it if I can, right? It actually treats it as like, oh, we're going to block out time for this every quarter. So definitely try out all three. Tell me how it goes. Like if y'all can figure out how to get the fix as you go to work, I'd love it. I think that like I want to hear the success stories there because like if that actually works, I think that I would like I think that that would that's why I would want to do it, but I just don't think that it's realistic. Okay, let's talk about the data migration models, and then we will be almost to the run books part of this presentation. So essentially, there are two ways to go when you're migrating things. And I have a good story here because Airbnb changed their mind on this, which was so crazy. So if you're building a new data model, so in that example I was talking about earlier where we like built a spec and we got all the stakeholders sign off and we build a pipeline and we backfill the pipeline and we have a pipeline running in production. And then there is still that time between when you have that pipeline running in production and when other people migrate and they depend on your data instead of the old data. There's like there's that time and there's like these parallel pipelines that both need to run. And one of the things about that is it's kind of expensive because then you're essentially paying 2x the cost of that pipeline for the duration of the migration. And that's like painful. And one of the things I noticed is that like when that happened, so initially the migrations I was working on at Airbnb, like when we made a new pipeline, it would take like 6 months for people to migrate. And then we just have two pipelines for 6 months. And then like sometimes it was like, is this even better? Like we're just adding another pipeline and we're holding on to both for 6 months. And this was actually a very common problem at Airbnb in 2021 where they were like, and eventually leadership came out and they said like, y'all are being too cautious. Like if things break and people need to migrate because the problem is like everyone is being too cautious about breaking other people's pipelines or making other people's data delayed. And they didn't drop the tables or stop the legacy or the deprecated pipelines soon enough. And so what ended up happening later on, they were essentially like, you give them a month. If they don't migrate in a month, you start breaking stuff. That's essentially what they changed their mind, right? So that we don't have this like crazy long period of time where like the migration takes forever and people are just deprioritizing moving the tables and backfilling and all that stuff because it's not fun. It's not fun. Migrating data is not fun. It's literally the least fun part of data engineering, all right? And it's like the most boring, least fun part of data engineering. So like I get why people don't do it. And so that's why like they only want to do it if they have to. And the way that you force them to do it is you delete the old pipeline and you make it so that their pipeline just doesn't run anymore because now their pipeline can't run because the upstream data doesn't exist. And the only way that they can get their pipeline to run again is by migrating. And that's why there's this the new one is called the bull in a china shop approach, where it's like, okay, once the new pipeline is up and running, like might as well migrate things. So like the way I did it when I was looking at like pricing and availability stuff was I was like, okay, we're going to move any of the ML stuff, any of the expensive things that like if they broke and were delayed, then we're going to migrate those. And then once those are migrated, everybody else can just break. And then they can migrate as soon as they can, right? And then they can just get their stuff to migrate because it doesn't matter that much, right? Because if it's delayed by a week, it still doesn't matter that much because their data set isn't that high impact anyway. And it's actually more impactful on the tech debt buildup and like on my own team's well-being to have two pipelines running in parallel for n number of months. So this is something that like I found very interesting, and I was very grateful that Airbnb changed their policy on this because freaking that first one was so painful. Where it was like essentially how it worked was like it was like 3 months where they run in parallel, and then after 3 months you rename you keep them both running in parallel, but the deprecated table you rename to like table underscore do not use, and then you have it run for another couple months, and then drop it off at that point. And I was always like, dude, like these zombie tables just need to freaking die, man. Like, why aren't these dying, right? And so definitely they both have their benefits and risks though, because the cautious approach, the thing about it is though, is that's a very it's a very accommodating way of doing data migrations. Because if you just break stuff, the thing is like the other team is gonna be like, hey, you just put work on my plate. Like, why are you doing that? Why are you being a dick? Why are you putting work on my plate? You don't want it. Yeah, you don't want that, right? So, but like they learned that that's actually the better way to go. That like it's because it's usually not that much work to migrate. So let's talk a little bit about on-call, proper on-call responsibilities. So there's a couple things here that I want to talk about. So one is around set up proper expectations with your stakeholders. I think this is the most important part of on-call because if you can get this right, then your on-call will usually be a breeze. Because at least like when I was working at Airbnb originally, the expectation was that any on-call bug was going to be troubleshooted in 4 hours, and I did that for 6 months, and I was like, I'm not doing this. Like, I'm not. 4 hours is stupid because then it's like if it fails at midnight, I have to troubleshoot by 4 a.m. Like, no, like I'm not doing this. And I changed it from 4 hours, and I was like, you know what we're doing? We're doing 24 hours. That's what we're doing. And like there was initially pushback because they were like, why are you making it worse? Why can't you do that? Because 4 hours freaking sucks. Like, and like I don't want to have to wake up in the middle of the night, and like it's bad for my mental health and bad for my well-being, and it makes me hate my job. And the thing, but also I told them that, but also another angle from it is that like it makes no impact on the downstream. There's actually no impact really on the downstream unless the data is more than a day delayed. So like that's I think good enough, and that's where you can have some really good conversations with your stakeholders. And the data engineer before you might have been crazy and done things in a way that like wasn't sustainable for you, and you might want to reset those expectations. And don't think like the on-call expectations going into the job are what they have to be forever. Like it is within your power to make changes to that. The other big thing, document every failure and bug. You'll usually get an email from Airflow or an email from your job orchestrator if something breaks. Make sure to document it and put it in some sort of Google Doc so that you can keep track of all the failures, so that you can find the problem children, so that like your on-call can get smoother and smoother and smoother. And obviously you have like on-call handoff, which is where that's where usually on-call lasts a week, and then you'll pass it to another person, and then that person will, and then you have to give them all the context of like anything that is currently broken or things that broke over that week. And then that's usually like a 20-30 minute meeting to sync up with people to get them to be ready for their on-call rotation. Okay, runbooks. Let's talk about runbooks a little bit, and we'll have a little bit of time to maybe create a little bit of a runbook. So complex pipelines need runbooks. Not every pipeline needs runbooks. You only need runbooks if like there's pipelines that have like a lot of inputs, or they have outputs that are used by a lot of teams, or they have a lot of complicated logic, or a lot of data quality checks, or like, things like that. Those are going to be the big things that you need in the runbook. And I think one of the things that's important here to differentiate is what's the difference between a runbook and a spec, because they are similar. And like some people actually say that they're the same, and the runbook it should be in the spec, and that like the runbook is just like an evolving part of the spec. So that's a big thing to remember. So the big things that you want to put in the runbook: primary and secondary owners. This is whether this goes in the runbook or the spec is like here or there. Usually if that's in the spec, it can be in the runbook too. And that's going to be like essentially the primary owner is like who you tap if you're on call and a pipeline breaks and you don't know how to troubleshoot it. The primary owner is who you tap. And if they're on vacation, you tap the secondary owner. And if they're on vacation, like you freak out. And like if a lot of times there isn't a secondary owner, and that can be a problem as well. Because I found that big tech doesn't do a good job at allocating 2 engineers for every pipeline, but that could be a thing. Another very important part of this is listing all the upstream owners, because one of the most common things that happens in data pipelines is the upstream data quality checks fail. And if you have upstream data quality checks fail, then you need to talk with those teams and be like, yo, your data sucks, fix it. And you want this to be teams, not individuals. The main reason for that is that team ownership fluctuates less than individual ownership, because reorgs happen less often than people leaving the company, people entering and leaving the company. So it's better to actually have the contact point be a team than to have the contact point be an individual, because then at least like that because that person might leave the company, and then you're screwed because you have no idea who like they are going to go to. So that's a big thing that I would imagine. And like, but even still, you can have reorgs that happen, and that team identifier might also be kind of bogus. So you want to be careful there. Another big thing here is common issues. So this is usually part of like the common issues is something that gets filled out over time. That usually the on-call person should be taking some of like if they're copying and looking at all those stack traces and failures that are happening, they should describe what happens and then the common way to troubleshoot it, right? And the common process to troubleshoot it, assuming that they can't fix it more long term, right? They can't like it's like just kind of a fundamental nature of the data as opposed to something that is like a bug, right? Where there are pipelines that are like that, like where you have like just like especially like I know like scraping pipelines. If you're like scraping the web or whatever, you're gonna have a lot of common issues that like just happen because you don't have control of the source data. Then you have critical downstream owners. These are the people that you need to talk to. These people are going to be the people who like especially you don't need to like document all your downstream owners. Like you just need to document the ones that matter the most, right? For me, it was like smart pricing was the big one. That was like the ML model downstream where it's like I knew if the pricing data was delayed, I had to talk with smart pricing quickly just so that they were aware that like the pipeline was going to be kicking back up and that I was troubleshooting it and figuring out what was going on. Last but not least is SLAs and agreements. So SLAs here is service level agreement, which is kind of duplicative here. SLAs and agreements, they're both agreements. And in this case, this is like, usually this is a number of hours, sometimes a number of days, number of hours or days after midnight for that day when the data is expected to arrive. And this is the agreement essentially between you and your stakeholders that says, okay, the data's not late until it's been this many hours after midnight. And that's going to be how you can kind of prevent a lot of your stakeholder questions from getting out of hand is by because they're not gonna be like, hey, why is it late? And then you're like, it's actually not late yet. It's gonna be late in like 5 hours. So don't quit pinging me right now. So that's a thing to remember as you're kind of like going through this stuff. So these are the kind of the critical aspects of a run book. And if you can have all these things in one doc, then you're gonna be in a good spot. There is stuff that's a pain, right? But here's an example, I think will kind of give you a better kind of view of what I mean by how runbooks can be helpful. So you have over here on the left, you have kind of your upstream owners, right? So you have like owned by Joe Mama, a monetization team. He owns coupons and credits. And then Henry on the finance team owns revenue. And then Karen on the customer service team owns the customer service data. And then you have your pipeline, and then these are your output data sets, and then these are your downstream consumers that you want to talk to if this stuff breaks, right? And some of the times, like depending on how mature your data infrastructure is, some of this stuff can be completely automated so that these people will actually be aware of a delay or aware of a breakage without you having to contact them, which is great. But like if it's a very long delay, they're going to ping you and be like, why is the data late? Like, why haven't you troubleshooted this, right? And so you want to be able to have a good conversation and a good communication with that person as well, so that you can have a kind of a picture in your mind of, okay, this is the person that I need to talk to. And generally speaking, when you're building these pipelines, this is just another part of this process that I find to be very valuable, which is not quite as technical, but is a good part of this process as well, is you should have a regularly recurring meeting with everybody on both sides of this. So, for example, in this case, I would probably have 3 maybe quarterly or monthly or quarterly one-on-ones with Joe Mama, Henry, and Karen, and then also with experimentation and pricing teams, customer service team, and the efficiency team. I would have at least a quarterly, if not a monthly one-on-one with each of those teams, so that we can just be all on the same page. And then also just to understand like where they're trying to go and if we can improve some of these data sets to make them better, so that like you get like, it's great because then in those cases, you just get a way better connection with all of your stakeholders, and you're just more integrated in the business overall. And you get a nice benefit from this of like, hey, we are the your stakeholders will be nicer to you when there's problems, because like you actually showed that you care about investing in the relationship over the long run. So it makes your life easier, because then you're like, oh, like because I ran into this problem of a long time, especially like early in my career when I was on call, was that like I would have stakeholders downstream who like were just like unnamed, right? Or like I just didn't even have a face to put on this stakeholder, because it was just like a lot of stakeholders or a lot of people, right? And then there's just like, I don't even know. I'm making unknown people angry by delaying their data sets, and so like, and I was always, that kind of stressed me out, and so I found that like you definitely want to do relationship building with all of your upstream and all of your downstream consumers as a data engineer, because then like you're gonna just catch things so much better, and it solves the other problems as well. It solves those duplicative data modeling problems. It solves like so much of the other kind of pieces of the puzzle. So we're gonna go create a new doc here, and then call this runbook for Exactly Inc. growth pipeline. Obviously, I'm a startup, so like I don't really have stakeholders, but we're gonna pretend that I do have stakeholders. So in this case, what we want to say here is you usually want like a title, right? We'll call this on call runbook for Exactly Inc. growth pipeline. Okay, so we have like our upstream data sets, and this is gonna be like events. We'll say like website events, and then we have user exports. Then we have downstream consumers. We have experimentation platform, and we have dashboards. We'll say both like that, right? User database exports. So these are going to be our two kind of different ways of doing things, right? And so we remember saying I was listing my upstream and downstream data sets, right? And then in here we have like common anomalies, right? Or like sometimes referrer is null too much. This is fixed downstream, but we are alerted about it because it messes with the metrics, right? Something like that. Because you can also have like data quality checks that are non-blocking, right? But they alert you because like they want to let you know that like you might need to talk with the dashboard users or the experimentation platform. And then you have like your user database, export might fail to be extracted on a given day. When this happens, export as soon as possible and just use use yesterday's. That's actually what it is. When this happens, use yesterday's export for today. Something like that, right? Depending on like how reliable your infrastructure is. Obviously, this isn't idempotent, and I hate it, but like that might be what your runbook is as a company, right? And so this is the idea, right? So you have like your common issues, like, and you probably want to call this like common issues, right? And then this is like bolded and like big, right? And then like obviously you have a primary owner. This is gonna be Zach. Secondary owner is Lulu, right? And then we have well, there was some more pieces of this, right? We have the run books, right? So primary upstream owners, common issues, critical data, and then SLAs and agreements, right? So let's put that in here so we can say SLAs. This is bigger. And then in this case, this is the data should land 4 hours after a UTC midnight or something like that, right? So obviously these run books, you're probably like, Zach, this is like the most ugly run book I've ever seen you write in your entire career. And you're kind of right about that. But the idea here, right, is now if someone goes to this pipeline and then they're like, oh, like I see this like referrer anomaly, and then it's like, boom, done, right? But then it's like, okay, and then you want to question like, okay, if that's the case, maybe we need to remove that check and just and make it so it's like a higher signal to noise ratio, where like the actual alerts are that way. But it's kind of hard to do that over the long run, like of just actually like fixing all your data quality checks, and like some of them are going to be noisy sometimes. But that's kind of the idea, right? And this is obviously I expect a lot more out of y'all because you're gonna like hopefully create a kind of a pipeline spec that is if you're in the combined group, you're lucky because you already created a spec that has a pipeline. But like if not, if you're like in the infrastructure group, then you need to also create just like a pipeline that describes things with inputs and outputs, and then it can also describe potential common issues and SLAs, so that this is going to be your homework for this week, and it's done in groups though, so you don't have to like it's a lot. I'm actually asking for quite a bit, especially if if you didn't do the analytics homework in week 3, then this is going to be a significant amount of work.
Congrats on getting to the end of the day 2 lecture. If you like this channel and like this bootcamp, make sure to like, comment, and subscribe, and share this content with your friends. I'm so happy that you're taking this time to invest in your knowledge and getting better at data. See you at the next one.